You found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey everybody, welcome to Dapper Reacts number, I don't know, what is this, 97, 98? 98, there it is. Evolution's Failed Predictions. So today, well, first of all, it's just me. I'm all by my lonesome, so, you know, I was thinking about trying to get someone on for this, but then I realized that I didn't actually know what I was going to be reacting to until, like, really late in this week, and I didn't want to spring this on anyone as a last-minute surprise. So I basically just ran out of time for me to feel comfortable asking people to come on such short notice. So today, it is just me. However, I do have some hard Baja Blast, which is, pretty great. And we are, of course, using the drinking rules that we use on Tuesday. We usually go over them on Tuesday, so I'm not going to go over them in full here, but do know that there are some ways that you can cause drink triggers. The easiest one is probably gifted memberships, because we drink once for each of those, up to about 20, then, you know, we just finish this drink and go get another one. There's also, if you super chat anything to the effect that answers in Genesis, AIG is a bag of dicks, we'll take a drink for that. And of course, if you send any super chats or membership milestone chats that include any of the kaiju emojis that we have just for members, we will also take a drink for that. So, yeah, there's those. Of course, you know, if you do decide to play along, first, you do not have to play along with alcohol. It's fine to play along with water, juice, tea, coffee, soda, a vape pen, high-fiving whoever you're watching with, high-five in the air, I don't care. Pet your dog, whatever. Those are all fine. But if you do decide to play along with an intoxicating substance, please be careful, know your limits, pace yourself. This is not a show where the drink triggers come with shots. No, these are like, you know, have a sip of beer. And if you decide to play, then be careful. Don't go out and then, you know, drive a car, operate heavy machinery, fly a plane, or text your ex. All of those are bad ideas. And myself, as well as the channel as a whole, do not take liability or responsibility for anything that you go out and do that is silly and harmful as a result of playing along. This is a play at your own risk game if you are playing with anything intoxicating. So, with that being said, oh, the 7-year-old wants you to know that we're here for you. Well, thank you very much, 7-year-old. That is from Jillian Flappy Ribs Wren. So, one quick little news for not this channel, but my second channel. So in case any of you don't know, I have a second channel called Top Hats Off, which is mostly tabletop RPG content. There's a little bit of other stuff on there too, but that is what's mostly been there for a while now. And it has just recently actually gained the ability to get super chats and channel memberships. So those channel memberships still give you access to my Discord server for all my supporters. They don't give you access to early access to videos on this channel though, but they do give you you know, stickers and whatnot over there, and there will be some member-only videos coming out over there. One thing that was actually requested by someone who is now currently a member over there is black screen versions of some of my TTRPG actual play sessions. So what I'm going to do is I'm going to, over the next few weeks, hopefully, download some of those videos, re-render them out without any visuals, and then just upload them as a members-only video and in a playlist for members only. So there you go. That is just a little bit of, you know, behind-the-scenes other stuff that I'm doing. So if you are interested in watching me and some other YouTubers and some of my viewers play some TTRPGs, we're doing Star Trek right now, head over there. It's a lot of fun. If any of my mods could put a link to Top Hats Off in the chat, that would be appreciated. That being said, we are here to take a look at a Creation Ministries International interview, podcast, vlog. I don't really know exactly what this is. It was on their YouTube channel. It is called 5 Failed Predictions of Evolution, or something to that effect. And it is a sort of the top 5 picked from an article called 40 Failed Predictions of Evolution, or Evolutionary Predictions, or something like that. So, in this, we are going to hopefully be getting the best predictions that evolution has ever made that did not come true. Spoilers, that is not what we're going to get. So Creation Ministries International, for those of you who don't know, is what used to be Answers in Genesis, until what is now Answers in Genesis split away and got to keep the name in the divorce. So this was the organization that Ken Ham was originally a part of when he went over to run Answers in Genesis America in the North American branch, which now it has a North American branch and a Canadian branch and whatnot. But it was originally an Australian organization that had international branches all over the place. And Ken Ham basically led a coup and just took all the American stuff. I have no idea how that was legal, but I don't really care. It's kind of a weird Game of Thrones-y story in which there were accusations thrown around of things like necrophilia and witchcraft, which is and demon possession, which is all sorts of crazy. So that's who we're talking about in here, is the original Answers in Genesis, who had to change their name after Ken Ham somehow got it in the divorce. Unless anyone has any real quick questions for me that aren't that, I'm going to hit play, and even if you do have real quick questions for me, put them in the chat. I'll probably answer anyway. It's not like I have anyone else here who's going to talk about stuff, it's just me. Alright, without further ado, here is creation.com with 5 failed predictions.
Scientific theories make successful predictions. Over the years, many evolutionists have made predictions.
And many of them have made successful predictions. One thing that I want to point out is that the predictions of evolution are all over the place, and they are routinely fulfilled in just about any paper you care to look at. Jillian Flappy Ribs Wren, who's been a member at the Amniote level for 20 months, says, for some reason YouTube doesn't want me to tell you about the stream I'm going on this afternoon, but it'll be fun. Oh, interesting. Let me know what the deal is there. Going on Vandalia's channel to talk Mayflower Compact. Interesting. Okay. Yeah, I don't think that's anything on my end that's blocking you from saying anything about that. It's possible that some weird thing that is hitting the internal YouTube moderation, which I don't have the ability to control. Because if I did, I would change how they do it. So. Oh, hey, there's Mothra. Let's drink for Mothra. Thank you very much, Mothra. Also, you know what? We're going to get a Dapper's a professional drink in here. Because I originally had this stream scheduled for an hour early, because I'm bad at this. So there we go. But yeah, almost every single paper that is published in biology today is itself a confirmed prediction, as long as it had positive results. Because remember, evolutionary theory is the single unifying theory of biology. It is the way that we make the vast majority of the predictions that are ever predicted in biology. So almost any confirmed prediction in any biological paper is a confirmed prediction for evolution.
But has the theory of evolution passed these tests?
Yes.
Don, you spent 20 years as a professional scientist and almost 30 years as a science communicator.
If he was... So actually, I don't actually know what the deal is with this guy. So let's see if we can figure this out. So this guy is Don Batten, and he has a page on creation.com. So let's see. He got his PhD from the University of Sydney, worked for 20 years as a horticulturalist with the New South Wales Department of Agriculture. Okay, so farming guy. That's definitely important stuff. His research included environmental adaptation of tropical/subtropical fruits such as mango, lychee, and custard apple, floral biology, floral induction, breeding, environmental psychology, especially water requirements, effects of water deficits. I don't know what environmental psychology really is, but hey. Plant taxonomy and mineral nutrition, blah, blah, blah. He joined the ministry in Brisbane, Australia in 1994 and has spoken around the world on the creation issue, showing the errors of evolutionary ideas he was taught. Okay, so he has been a science miscommunicator for 30 years. So that's, what else were we going to expect? But yeah, that is his background. Goopdo3 for $5 says, if you did control YouTube moderations, you would let us say what AIG is. This is accurate. Yes, I would. That would, in fact, be one of the things I would change. Specifically, I would let you say it in English, uncoded. Alright.
You say that successful predictions don't necessarily prove a theory right, but unsuccessful predictions or failed predictions can disprove a theory. What's the difference?
So, that is, to some extent, correct, right? If you have... It is easier to disconfirm a theory than to conclusively confirm it. In fact, I would say that you can't conclusively confirm a theory. However, every single time you have a successful prediction that other explanations for whatever it is you're studying could not or did not make, or that they made contra to what your hypothesis or theory is, that is in fact extremely good evidence. So if you can't come up with successful predictions, you're basically wrong. And if you can, that is extremely good evidence that you're right, especially if those predictions are in contrast to the predictions of other people's ideas. So that is there is a distinction there. I wonder if Don Batten is going to get this right.
That's correct. Science actually advances by disproving theory.
PhD in plant science. I'm sure that's what his degree says right there on the diploma. I'm sure it said, Don Batten is hereby awarded by the University of Sydney, or what was it, New South Wales? I don't remember. A degree, a doctorate in plant science.
Rather than proving them, because a fulfilled prediction is actually a formal fallacy, and it's called affirming the consequent, which sounds fancy, but we'll explain it.
It's not actually. It's okay, sure. You know, I'm going to take a drink. For a confirmed prediction is affirming the consequent. No. It is if you take it as logical proof, right? So affirming the consequent goes like, if P then Q, Q therefore P. But that's not what science is doing, right? Because if you think about it, if P therefore Q doesn't mean Q only if P, which means that there are other options that could fulfill or could predict Q that are not P. And you can't differentiate between them, right? So I could say something like, if I have a let's see, a burnt log that in the fire pit outside. That means someone had a fire in the fire pit last night. Or to put it more correctly, if someone had a fire in the fire pit last night, there should be a burnt log in the fire pit. Okay, that seems to follow. But if I go outside and find a burnt log, does it necessarily follow that someone had a fire out there? Well, not necessarily. What if someone burnt a log in a different pit and then just transported it to the fire pit at my yard? Seems unlikely, but I can't technically rule it out just because there's a log in there. But what I could do is, if I kept making additional predictions, saying like, okay, well, if someone had a fire out there, then I should also expect to see that other things, like there should be additional ash and debris that has flown up out of the fire pit and come out to rest on the ground around it. Or if I had a security camera out there, that should also show that someone was out there with a fire. And I can keep making these predictions, and other ideas can't. Then I have good reason to accept. And I'm no longer just looking at this in a purely strict logical sense. I'm using an empirical method. Because remember, science isn't about strict formal logic. Empiricism itself is basically impossible to derive from just pure logic. You have to make assumptions about the world that are not actually required of strict formal logic. One of them is that basically the universe operates according to consistent rules. Without that, you could not get from your data to a conclusion to predictions. So no, scientific confirmations of predictions in science are not affirming the consequent because we're not using them in the framework of strict formal logic. And also, Starsong, who's been a member for 6 months and is at the Tetchpod level, says, Happy Holidays. Well, happy holidays back at you. I am slowly gearing up for American Thanksgiving. I have a bird. I have potatoes. I have stuffing, green beans. I've got cranberry sauce, gravy. I need to still go to the store, get some herbs. I need to get a whole lot more butter because I'm down to half a stick, which is not going to be sufficient for Thanksgiving. I'm also probably going to get some bacon to drape over the turkey to help keep it nice and moist. So, yeah.
So, an example of a simple prediction might be that all horses are brown.
Okay.
Right. But unless I knew that I had observed all horses, I'd seen all horses that exist, I wouldn't know that was true. But I only have to see one white horse to know that it's failed. It's a failed theory.
Yeah, he's right here. it is easier to disconfirm than to confirm, which is why in scientific experiments, typically, what you actually do is you have your hypothesis, but then you have your null hypothesis, which is your hypothesis that is basically a default position. So if your position is all horses are brown, then your null hypothesis is all horses are not brown. And then what you do is you go and gather statistical data about your hypothesis based on whatever experiment or observations you're doing. And then you see, is there statistical, not logically positive, but statistical reason to reject the null hypothesis? And if there is, then what you can do is you can say this is itself evidence to indicate that perhaps we should tentatively accept the hypothesis. Metageeky with their 5th super chat says, emergency butter funding. That's a crisis. Thank you very much. Yes. I was going to say 100% of the proceeds of this video will go towards butter, but then I really quickly realized that might result in me buying way more butter than I should. So, I'm not going to do that, because that could turn into a disaster. Like, if I had to buy, like, I don't know, like, if you guys gave me $100 and I had to buy $100 worth of butter, I wouldn't have any place to put it. So I'm not going to do that. But some of the funding from the stream will go towards butter.
So that's how science advances, by disproving theories, not by proving them.
Yeah, hey, that's right. I'll take a drink for it. He is basically correct about this. He's wrong that it's affirming the consequent, because remember, science is not saying if P then Q, Q4 therefore P. That is not what's happening. So science is not using formal logic, it is using empirical statistical methods. So there you go.
So if a prediction is not...
Just buy fancy schmancy butter. I don't even know if I have butter that I could get in time for Thanksgiving that I could spend that much on and like still be able to store it. Because I know I could get like fancy butter from France or something, but like I can't just go to the grocery store and get that. An intrigued feline says, just state all of the funding will go towards sustenance. I can say that with, very high confidence. In fact, if we can get to the Bent Gets Free pizza, it'll even get Bent some sustenance. So, we don't want Bent to starve between now and Thanksgiving.
Not borne out, then it's actually disproof the theory. And science...
So, one thing that's important is that while a failed prediction is in fact, in the strictest sense, disproof, it means that you were wrong, it does not mean that you have to completely abandon the previous hypothesis. If a hypothesis or theory has been making very good predictions for a very long time about a wide range of things, and one thing changes that, the first thing you normally look at is, was there an error with my experimental design or with my observations? Was there an instrument error? Was there a methodological error? And a lot of times that ends up being what the case is. And so you fix that and you go back and then it turns out, oh, hey, look, I got the results that I predicted within a margin of error. Another thing could be that maybe what you've actually found is a small problem with your hypothesis. And so it actually just needs to be tweaked a little bit. And that is the next thing that you're going to look at. You're going to say, okay, well, if I've managed to rule out any kind of methodological problems, if I know that I'm not making any mistakes in my math, if I know I don't have any instrument error, okay, what about my hypothesis can I change to bring the actual results in line with predicted results? And only if you can't do that is it really time to just go back to the drawing board and start back over. Because generally speaking, if you're smart enough to know how to make a good hypothesis in a field, you're probably not making one that's just completely wrong. You're probably coming up with something that has some good chance of being right. Now, of course, if you're not an expert in a field and you're just some guy who's doing an experiment, then who knows? Maybe you're completely off. But at this point, yeah, we're not at the point where we normally just go back to the drawing board completely. It's much easier to tweak things and get a more accurate prediction and then go check that. So he's simplifying this down to the point where it might be kind of wrong. So,
or rather the evolutionary ideas, there are actually many failed predictions. I've written an article with over 40 of them. We're going to deal with 5 today.
So presumably the best 5.
Okay, that sounds good. Now, I've heard a few different terms talked about when people say evolution, and I've heard cosmic evolution thrown in the mix.
Yeah, so the reason they say cosmic evolution is because when you just say evolution in the context of science, people generally interpret that to mean the biological evolution, theory of evolution in biology. So things like, the diversification and change of populations of reproducing organisms over time. And so when you say 5 failed predictions of evolution, I'm going to assume that you mean of biological evolution. So if we start talking about the Big Bang, well, you're talking about something that isn't evolution. You're talking about the Big Bang. Yeah, Vadim Radchenko, 6 kinds of evolution. Also, all Christians are Catholics? I mean, they're not going to say that. Hollywood tends to think that. It's actually one of the tropes about Hollywood, especially horror movies, that annoys me, is that Christianity just equals Catholicism, as if like there weren't lots of other kinds of Christians, especially when the movies are set in like the United States, where like that's not even the majority of Christians in the United States. Like there are more Protestants than Catholics. If you want to go like by denomination, then yeah, the Catholic Church is the biggest one, but that's because you're subdividing all those Protestant groups. Catholics are not the majority of Christians in the U.S.
Can you explain a bit more about evolution and the different terms people use for it?
Yeah, so today we're dealing with cosmic evolution, which is the grand scheme, that how everything came to be.
There is no such theory. So there are ideas like the Big Bang, which tells us how the universe at a large scale came into its present relatively sparsely populated, relatively cool state out of an initial extremely dense and extremely low entropy and extremely hot state. That's one thing. Then you could talk about theories of galaxy formation, which I don't like, the Lambda CDM, which is the current best fit model for after the initial expansion, how the universe progressed. You could talk about things like the nebular hypothesis for star and solar and star system formation. You could talk about planetary formation within that as its own separate field. You could talk about the geology of the Earth, but none of these things are evolution. These all have separate names for a reason, because they don't fundamentally depend on each other, right? If it is true that God just poofed the Earth into existence out of absolute nothing 4.5 billion years ago, and then just let it go on its way, that wouldn't change anything about biology. If we found out that actually the universe was just a steady state, and it only looks like there was a Big Bang, that's actually fake, and so steady state universe is back, that doesn't do anything to biological evolution. Similarly, if biological evolution is proven to be absolutely impossible, that does not get rid of the evidence for the age of the Earth or the Big Bang or any of those things. So basically what this is he is trying to combine all of these things as if they were actually all dependent on each other and were causally related in some important way. And then that way, if he can slip in doubt of any of them, he can then create in the minds of his audience doubt about all of them. So, yeah.
By natural processes over billions of years, from the Big Bang to us.
Okay.
We're rearranged stardust type of idea. So cosmic evolution is the grand scheme, and it involves cosmological evolution, which is the evolution of the universe. It involves geological evolution, which is...
That's not even a real term that people use. I'm just taking a drink for geological evolution.
Is the development of the Earth and its rocks and fossils and everything, and it involves biological evolution.
Good23 for $2 says Dapper knows a lot about an extremely hot state. Thank you. Much appreciated.
Which is the development of all the living things. So there's sort of 3 broad categories of evolution.
Well, I mean, I guess that's better than the 6 from Hovind, but no, there isn't. Basically, of all of these, sometimes you might get someone talking about cosmic evolution, and then other than that, there's like stellar evolution, which is the actual formation and lifetime of a star until it turns into a stellar remnant. But like that's it. Evolution is not normally used around these terms, and again, the only reason he's trying to do this is to fallaciously link them all together in people's minds.
Okay, well, let's start with...
Yeah, as Pegajay says, basically evolution is any science that disagrees with their interpretation of the Bible. Exactly. Yep. Which, spoiler alerts, is basically all of science. we would have to be wrong about essentially all of science in order for young Earth creationism to be even plausible.
Cosmological evolution. Can you give me an example of a failed prediction from cosmological evolution?
Yes, well, according to the Big Bang, which is the favoured model of how everything came to be, galaxies and things develop over time. So young galaxies, right near the beginning, would not be spiral galaxies like our Milky Way. The Milky Way is considered a mature galaxy. And so galaxies are supposed to evolve or change over time, start out quite simple and become quite complex.
So he is broadly right about that, so we'll take a drink. It is indeed a prediction of the Big Bang.
So when the Hubble Space Telescope was looking way, way, way away, a long way away, supposedly close to the origin of the universe, they kept seeing mature galaxies.
This is actually not something that Hubble was noticing. This is more of a James Webb Space Telescope. But, whatever.
Which was rather a puzzle because it didn't fit the expectation or the prediction. But they thought, oh, well, the James Webb Space Telescope, it's you can see much further than the Hubble telescope and gives us clearer images. So when the Hubble was basically replaced, well, it's still working, but the James Webb Space Telescope came on board, we'll be able to clarify this. Well, what they found is with the James Webb Space Telescope is that as far as you can see, there are mature galaxies like the Milky Way.
Okay, so that is basically just not true. So, after initial data came out, it did seem like there were strangely large galaxies, but not the spiral galaxy is actually not the important part. The important part is the mass of the galaxies. The spiral structure is just a result of gravitational interactions between... Oh, take a drink from Mothra, I guess. It is a... Thank you, Mothra. It is a result of gravitational interactions between the main galaxy and some other source of gravity. So, for instance, in the Milky Way, it seems like the Magellanic Clouds are probably what's maintaining the spiral arms in the Milky Way. So, those can form relatively quickly on like a galactic timescale. We don't really need an explanation for just the presence of spirals per se. The weird thing is the large masses of these galaxies. And the reason that's significant is basically until you get large enough to have smaller satellite galaxies, you're probably not going to get spirals in the first place. So you can use the existence of spirals as a kind of a proxy for quote-unquote maturity of a galaxy, but it doesn't actually work that way. So when the initial data came in from the James Webb Space Telescope, what was noticed is that there were very, very distant but very, very big galaxies. And by big, I mean in terms of mass. So why is that? Well, it turns out that a big portion of that was actually just the techniques that were used to determine how far away those galaxies are. So at this kind of distance, we really use redshift. So redshift is just a Doppler effect applied to light. So if you've ever seen an oncoming car where it has a high pitch as it's coming towards you, and then it passes you and the pitch starts to lower, and then it gets deeper in pitch as it goes past you. That's just the Doppler effect. If a light source is moving towards you, the color of that light will be shifted towards blue or shorter wavelengths. If it's moving away from you, it will be shifted towards red or longer wavelengths. Now, there are a couple ways that you can figure out the redshift of a galaxy. One of the quick and easy ways is to just figure out what is the expected wavelength, peak wavelength, of just a galaxy, and what is it we're getting from the galaxy. And that is very easy because you don't need much data, and it doesn't need much data processing, because you can just compare expected peak wavelength to received peak wavelength. You can figure out what that difference is, which then tells you how much redshift there is, which then you can use with the cosmological constant to calculate an approximate distance. Easy. It's actually... Well, it's usually not taught in public schools in the United States. It doesn't use math that isn't taught in public schools. So, like, a high schooler, like a senior in high school in the United States, who is decent at math, should be able to figure out all of the math required to do that kind of thing. So when using that, a lot of galaxies that were really significantly big were getting extremely high redshift values. Let's see. An Intrigued Feline says, can we have a shout out to Dr. Becky, who has a YouTube channel specializing in black holes and also covers extended early universe? Yes, actually, Dr. Becky is indeed a good person to go check out on this. I would normally not feel like she needs one of my shout outs because she's a much bigger creator than I am. But yeah, if you are not already watching Dr. Becky for stuff like space news and things like that, you probably should. She has an excellent channel. I don't watch every video, but I do try to keep up here and there, and I've never seen a video of hers that I was disappointed with. So, yeah, there you go. All right, so is this a problem? Well, it turns out that that particular method of estimating distance, where you're just naively comparing expected versus measured peak wavelength of a galaxy, has a lot of problems that can mess up the calculations. Something as simple as an intervening dust cloud can cause changes because some of the light will scatter off of the dust, which can shift the peak wavelength towards longer wavelengths just by existing. Now, does a dust cloud actually mean that the galaxy you're seeing through it is farther away? Well, no, of course not. That would be crazy. That's not what happens. So, a better way to do this, but that requires much more data and is much more computationally intensive, is to actually check for emission or absorption spectra and see how they've shifted. So, basically, when various chemicals are excited, as they cool down, or as they lose energy, they shed photons of particular wavelengths, and they also tend to absorb photons of particular wavelengths. And because we know what these are for every element, we can check a spectrum to see where there are holes in the lines that are absorption spectra, or where there are anomalously bright spots in the spectrum, which are emission spectra. And since we know where those have to be if a sample is at rest relative to us, we can measure the difference between where those are and where the, experimentally derived actual quote-unquote true values for these spectra are. And that is not something that's going to be interrupted by dust. What dust will do is it will simply eliminate certain parts of the spectrum, which still leaves you with the other parts of the spectrum that have these wavelengths in them that you can check on. And it turns out that when we do this, these galaxies are actually much closer than we were initially measuring them to be. Also, Ben has changed their name, so let me make sure I get it right. Ben, slipping gracefully toward the Malfic Tunicate, has gifted 10 Dapper Dinosaur memberships. Thank you so much. So let's add those 10 in, and we will take 10 drinks. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, now, so we found these distant galaxies, and they're not as distant as we initially thought, which does make up for a lot of the supposed problem. Now, that also helps with the not really a problem Hubble, but whatever. Now, it is still the case that some of them do seem to be weirdly large. We're not sure why. And so, that probably does mean that we actually do have some work to do with our current model for the Big Bang. And that's good. That's what we want. We want to refine the Big Bang model. But remember, it remains the case that the only reason to have a cosmic background radiation, or microwave background radiation, whatever, the CMB, the only reason it exists is, or could exist realistically, is if the universe started in a very hot, dense state with a much smaller scale factor than it has now. And the only reason, or the only thing that could cause the observed effect that virtually all galaxies are moving away from us and moving away from each other, again, is if the universe started with a much smaller scale factor and is currently expanding. Which means that while we probably do need to make some minor tweaks to our models surrounding galaxy formation in the first, few hundred million years after t equals 0 of the Big Bang, it in no way invalidates the Big Bang as an idea. In order to do that, you would have to show that things like, actually, the cosmic microwave background radiation isn't the result of the, universe becoming clear, optically clear for the first time, ever since having been, a giant soup of plasma. Or you would have to do things like say, well, actually, we don't see redshift from most galaxies. That's actually a result of, and then you had to come up with an explanation that looks like redshift, but that isn't. And importantly, that you can test between your version and the one we see. And those things are fantastically unlikely. So as it stands right now, the universe is expanding, which means it was more compact in the past. And if you run that clock backwards, you get to a scale factor of 0 at some point. Now, was the scale factor actually 0? I doubt it. There's probably some kind of physics that we don't understand that would prevent the actual complete collapse of all space and time. But maybe I'm wrong. In fact, if I were wrong, that would mean that space and time have a beginning, which I would think most theists would like. You would think that that would be a win for them, since most of them say that there's a finite period of existence for the universe when it started. So I personally think that if you are a big fan of the idea of a god creating the universe, you should be a big fan of the Big Bang. Because that is a very easy place to say, look, that is the creation of the universe. But hey, I'm not here to give people theological advice, although I seem to do it a lot, so maybe that is why I'm here. Who knows?
And this is a big problem for the naturalistic Big Bang idea of the origin of the universe.
It's really not. It's a minor problem for models of galaxy formation. That's it.
It's a huge problem, a huge fail.
Oh my goodness, I'm taking a drink. Sorry, Don Batten, you probably shouldn't be saying huge fail. It just doesn't work for you.
So, yeah, that's actually much more consistent with God creating the universe like the Bible says.
No, because according to your version of the Bible says, God created the universe more or less as it is 6,000 years ago. We shouldn't see any difference in distant galaxies, something which, by the way, creationist astronomers have acknowledged. But then they just seem to kind of gloss over the fact that we do, in fact, see differences in distant galaxies. They don't look just like nearby galaxies. But also, that doesn't explain the ubiquitous redshift. It doesn't explain the CMBR. It doesn't explain any of these things. So, yeah, no, it doesn't at all fit. So even though it is a minor problem for models of galaxy formation in the wake of the initial expansion of the universe, it's not a problem for the Big Bang per se, and it absolutely does not even come close to matching the Bible. It still flatly contradicts his interpretation of the Bible. Let's see. Vadim Marchenko says, Lemaitre was against that, but the Pope was pro that idea, the idea that, the Big Bang is the creation of the universe. Yeah, I mean, honestly, I don't get why creationists, broadly speaking, don't just take the Big Bang as a win. Right? Because think about it. For millennia, many versions of theism, especially the Abrahamic versions of theism, including the big three like Christianity, Islam, and Judaism, but also some of the more minor ones like Mandaism, Hebrew Samaritans, or Samaritan Israelites, whatever you want to call them. Even relatively newer ones like Rastafarianism, they've all been saying, yeah, the universe was created at a certain point by God. And up until the Big Bang, and a lot of the data was coming in around that time, around like the time of Lemaitre, most scientists were like, nope, the universe is in a steady state. It's been eternal. There's no need for any of this kind of like, when did the universe come into being kind of thing. We can just extend it infinitely back into the past. And then the data came back on the Big Bang, and you couldn't. The prediction of the steady state was wrong. And I don't see why most theists don't take the fact that they were saying that there was an origin to the universe as a confirmed prediction. I would. The fact that they don't is or that they don't all do that is baffling to me. Cognitive Trifurcation, who's been a member for 8 months and is at the amulet level, says, by this guy's logic, the inconsistency of how many donkeys Jesus rode on is a massive problem for the accuracy of the New Testament, and CMI is an AIG, and I'll take a drink for that. No, there's no inconsistency. He just came in riding across 2 different donkeys. Problem solved. That's actually a bit of a meme in some circles in like Bible scholarship, is Jesus riding into Jerusalem spread across 2 donkeys.
And that would explain why the galaxies are mature as far as you can see.
They all look
But they're not, though.
mature.
No, they don't.
So that's pretty strong evidence.
That's just a lie. They don't. They do not look as early as was originally expected, but it also turns out that they don't look as primitive as we thought they did at first. And so there's less of a problem than was initially thought, and they in no way look like galaxies in the nearby like parts of the universe, like Andromeda or the local cluster. That is not the case. That is just a lie.
Evidence.
And also you find heavy elements. Say, for example, the first stars are supposed to be just hydrogen, a bit of helium, and then they're supposed to form the stars with, like our sun, which have all the other elements, carbon and nitrogen and so on. And so the early stars, early galaxies wouldn't have had any of these heavy elements. Well, what they're finding is that these galaxies have heavy elements, the carbon and nitrogen and so on, and metal and so on.
So he's right that the earliest galaxies and stars shouldn't have had anything higher than lithium, and probably nothing much detectable higher than helium. But the problem is that no one is suspecting that what we are seeing when we look at James Webb Space Telescope's galaxies are galaxies composed of the very first generation of stars. The reason for that is that that very first generation of stars was almost certainly extremely short-lived, because they were almost certainly extremely high-mass stars, possibly higher mass than anything that we see forming today, and therefore went through their entire life cycle in the span of maybe a few million or even a few 100,000 years, and then went supernova, spreading the very early universe and getting it full of heavy metals and heavier elements and whatnot. So unless he has really good evidence to say that what we're actually seeing is far enough away and in just a small enough window to be actually seeing the first generation of stars ever, which no one is saying we are, then this prediction isn't an actual prediction. No one is actually making the prediction that we should see zero metallicity stars in these distant galaxies, because they're not the right age. We're not looking back far enough. It's not even clear that we could look back that far.
They're there. They shouldn't be there.
Wow. Can you give us some examples of failed predictions in evolutionary geology?
Which isn't a thing. So far, we are no predictions of evolution. One prediction that is not really a failed prediction from the Big Bang, and a sort of partially failed prediction of galaxy formation models. That's not as badly failed as he would like us to believe, but that, yeah, probably does require some tweaking in our models of galaxy formation. So, hooray! We have some new things to learn about galaxy formation, which is the entire takeaway of that entire thing.
Yeah, there are lots of those. I mean, a big one is, back in the 1950s, 1954, a geology textbook on geomorphology was published as a major textbook widely used. And the prediction was made in there that planation surfaces, which are the flat surfaces you find all around the world, planation surfaces would be young, less than 2 million years. Now you think, well, that's a long time. 2 million years is a long time. But
it is. It's much longer than he thinks the universe has been around.
Compared to the supposed age of the Earth of 4,500 million years, 2 million years is a drop in the ocean.
4,500 million years. Just say 4.5 billion, dude. What is it with people saying 1,000 million instead of just saying billion? I hate that.
Difference.
A big difference. So basically, the prediction was made that these planation surfaces would be less than 2 million years in age. Well, according to radiometric dating, for example, up in the northwest of Western Australia, the Kimberley Plateau is supposed to be 540 million years old, and yet it's flat. And the problem is that...
Okay, did you see what he did there? You might not have caught it. This is a subtle thing that he's done here. He said that the planation surface should be young, but when radiometrically tested, the rocks turned out to be far older than the predicted age of the planation surface. But what's the problem there? In order for a planation surface to form, in order for a landscape to weather flat, the landscape that is has to be made of rocks older than the erosion that eroded it flat. How much older? There's no upper limit. We have a goofball Gorgon also known as Utskea, who's been a member for 14 months and is at the tetrapod level, who says bag plus cock equals AIG, and I will take a drink for that. Thank you very much. All right. A couple things here. Let's see. Jillian Flappy Ribs Wren says because billion is different in British English, it's what Americans call 10 billion. Yeah, but all right. You know what? That's probably actually a good reason. I still don't like it, though. Sealip says, I'm going to have to do with billion having a different... Yeah, okay, yeah, same thing. British versus American. Yes, okay. I still don't like it. I hate it. And the fact that the British are wrong about numbers just means that they should learn how to count properly. That's all that means. Hey, British people, learn how to count. Just figure it out. All right, so, yeah, the rocks. Oh, but first Star Song for $5 says... Long form numbers versus short form numbers. Short form numbers are mostly used now. Shara Bradford for $10 redo says it's too early to listen to an Aussie talking rubbish. I'm going back to sleep, and we'll listen to this after coffee. It's too early in the morning here. Please don't judge all Aussies the same. Look, I would absolutely never judge all of Australians the same way. I have long maintained that, for one thing, look, y'all are probably have a lower proportion of absolute batty crazy people over there than we do here in the United States. In fact, the fact that people like this guy and Ken Ham and Taz Walker and Andrew Snelling are all in the United States now is at least in part because Aussies don't like to put up with that nonsense. And so they have to run to the United States where there's a whole community of crazies that they can hang out in and get donations from. So don't worry, I do not judge Australia on the basis of like the refuse that ran away from your country. So, DM the rocks don't lie. Wing says learn metric Britain. I mean, to be fair, Britain actually does still use a lot of non-metric measurements. They still measure a lot of things in miles and stones and inches and whatnot. So, let's see. And a tree fan says, why must the British conform to the Americans when it is the Americans that decided to change the language? Actually, in most areas, American English is actually more conservative than British English in terms of how English was spoken before those varieties started to really drift apart. So, did Americans change the language? Certainly not more than the British did. The British certainly have changed English more than the Americans have. In fact, my accent is actually much closer to what was spoken in England around the time of England starting the colonies in the what would become the United States than anything spoken in England today.
Why they made that prediction about 2 million years is that the observed erosion rate on the Earth was such that all of the continents above sea level would be eroded to sea level in just about 20 million years.
Okay, we're going to take a drink for that too. It is physically impossible for that to happen. There are two major reasons for this. One is that there is such a thing as uplift. There are places where the erosion rate is essentially negative, right? Where you gain elevation over time. Many volcanoes are in this situation. Famously, the Himalayas are in this situation. Mount Everest is higher today than it ever has been before. And you can say that just about every day of your life. So there's that problem. And second, the rate of erosion actually decreases and approaches zero as the land gets towards sea level. That's a thing. If there's not enough energy gradient between the high points and the sea level, then there's less energy available to wash away weathered sediment, which means the erosion rate goes down. So no, under no amount of time, given geological activity on Earth, will you see continents erode to zero. Renee, intellectually gerrymandered reborn, for $2 says AIG is a bag of famous ginger beer. A Cock and Bull. Yes, Cock and Bull. I do like that brand. It's not the only one I go for, but it is definitely on the list of ginger beers that I'll have, and I will take a drink for that. Thank you very much. So, first, he was wrong about what it means for a planation surface to be old. It doesn't mean that the literal rocks are old. Radiometrically dating a rock that is on a planation surface does not tell you how old the surface is. It tells you how old the rock is. You can think about it like this. If I told you that a wood carving was made 10 years ago, but then you checked like the age of the wood, and it said it was 100 years old. Does that mean I'm lying about how old the wood carving is? No, because it was probably carved 10 years ago from wood that was cut down much longer ago. Who cares? That's not a problem. That's not even a failed prediction. That's just Don here not knowing how words work. And then his other claim that like this was based on how long it would take for the continents to erode to zero is also a lie, because the continents won't run out to zero. You can't simply extend current average erosion rates over some wide area linearly into the future, or into the past for that matter. It doesn't work. It's another example where creationists will take any rate that they know shouldn't be run infinitely back into the past or into the future, because it will obviously be wrong, and then say, well, if we could do that, then that would be a problem for science, so we should do that. While then also ignoring the fact that there are certain rates in the world that are based on fundamental aspects of physics that do not vary, and they'll be like, but what if they were different in the past? One of those being radiometric decay, right? Which just directly depends on the strength of nuclear forces, which are just constants in physics. And I was like, wow, what if that changed? But erosion rates? No, we can totally just infinitely extend those into the past and future. That's perfectly fine.
So erosion is wearing the surface of the earth. And when you've got different types of rocks and things, some rocks erode faster than others. And so you would, if you have all this erosion going on, you can't have a flat surface. You get...
Actually, no, that is in fact wrong. This is basic geomorphology, which to be fair, I'm not an expert in. But there are a lot of geomorphology principles, things like meandering rivers, the way that wind erodes, that means that on average, many surfaces will be turned into flat surfaces. So for instance, with our river meandering, over the entire extent of the meander, it will meander back and forth over geological time, which will tend to evenly erode wide swaths of landscape. Now you might say, but there are things there are rocks that are going to be harder or, easier to erode. And that's true. But on a long time scale, it's going to not be a huge problem. And it's also the case that planation surfaces aren't perfect planes anyway. So yeah, there are differences in the erosion rate. Philip Punk says, carve a piece of wood before the wood exists. That would be interesting. I suppose you could actually kind of do that if you put like a very hard mold around a tree that was going to grow to be bigger than that piece of like that mold would be. And then when you remove the mold, you should have a tree that has grown into the shape of the mold, which if it was originally some kind of statue shape, could actually get you wood that you had quote unquote carved before it existed. People do that with pumpkins. They'll put like a hard plastic shell around a pumpkin of a particular shape, and then when the pumpkin is grown, they'll take that shell off, and the pumpkin will have grown to fill in the shape. You can also do it with watermelons. In Japan, you can actually get box-shaped watermelons that are grown inside box-shaped plastic molds that are therefore easier to ship. So, I guess you could technically do that in that sense, which would be pretty cool.
Gullies and it becomes uneven. So
it doesn't. That's the thing. The reason that not every place has gullies and valleys and canyons and whatnot is because different kinds of erosion happen in different circumstances. Right? Like, this is not some kind of thing that like no one has thought about. There's an entire subfield in geology called geomorphology that goes into all of these things. Planation surfaces are actually one of the most common kinds of large-scale erosion. It's not like we need to explain this planation surfaces. What we really need to explain is why valleys and canyons occur at all. That's actually the more unusual feature.
So those flat surfaces couldn't be old. And here we have 40 million years supposedly, and it's still flat.
No, you haven't shown that. You can't show how old a surface is by dating the rocks it's composed of. Because again, the planation surface is a logical necessity younger than the rocks it's composed of. I'm taking another drink for this. I don't see how this is something that he hasn't thought of. Or if it is, I guess maybe he's just lying to us. Obstinate Sparrow says, when do we get evolution? This is creationism, which means that we'll be lucky if we actually get like one actual thing that evolution would have anything to do with.
So this is a big problem. It actually matches the Bible's account of Noah's flood. The Noah's flood would have created these surfaces just thousands of years ago, and consequently they haven't had time to erode.
That is also not true. In fact, floods are particularly good at carving out valleys with particularly shaped channels. So, for instance, it usually creates U-shaped channels in surfaces, and it is actually really, really, really bad at leaving behind planation surfaces. In fact, the biggest flood caused terrain that we have are the channeled scablands over in places like Washington and parts of Oregon, where they are gigantic end of the last glacial period flood spillways. And they're absolutely not flat. In fact, the channeled scablands might give you an indication that they're channeled. They have channels in them. They're full of spillways with gigantic hills made of ripples and channeled surfaces that have U-shaped valleys in them. So it is literally the opposite of what you would expect from runoff of a global flood. It could not be more different. A flood precludes extensive planation surfaces, because planation surfaces are generally things that occur over the course of hundreds of thousands, not single years, and are not the result of high energy events, but rather relatively low energy events.
And you see them all around the world. They're actually testimony to Noah's flood.
Right, so this flood.
Yes, nothing says Noah's flood like geoformations that could not possibly have been formed by a flood, never mind a global one.
Surfaces, they don't point to millions of years, they actually point to a catastrophic flood from the Bible.
Yeah,
instead.
and they point to a young Earth.
Literally the opposite of what's true. I'm taking a drink. Star Song for $5 says, creationist's favorite site, the Grand Canyon, disproves the flood for all they like to cite it. It's true. The Grand Canyon absolutely precludes formation in any kind of flood environment. And the quickest way to realize that is switchbacks. The Grand Canyon has what are called switchbacks, where on one side, the river is flowing one direction, and on the other side of the switchback, it flows the exact opposite direction in a short period of, like a short space, and then it goes on its normal course. Those only happen as a result of a meandering river, which begins to form a valley or a canyon, right? Which means that originally, the river that started forming the Grand Canyon was actually doing planation stuff, which you can see in the surrounding plateau, because it is itself relatively flat, and is probably a planation surface. And then, I don't remember exactly what reason, I believe it was actually possibly started by a flood. Actually, that's a pretty popular idea, is that there was the Lake Missoula flood, which started carving the Grand Canyon in what was already just the riverbed of the Colorado River. And that actually started it going incising down into a canyon, rather than just remaining a meandering river, which was going to continue planating the surface. So, yeah, that's... Ironically, in having a flood involved in the formation of the Grand Canyon, which itself is surrounded by a plain, we are showing why floods do the opposite of create planation surfaces. They literally cause valleys and canyons, not flat surfaces.
Fantastic. Well, can you share some more examples from geology?
Well, more
Good. More stuff that's not evolution.
in the area of paleontology, which is related to geology. So this is a study of fossils in the rocks.
Mm-hmm.
Two are closely related. So this one goes back to Charles Darwin, in fact. And Darwin predicted that no organism wholly soft would be preserved as a fossil. For example, jellyfish or octopuses and things like that. There's almost nothing.
Hey, octopus have hard parts. They have beaks. But yeah, they're almost entirely soft-bodied.
To preserve, they're just soft-bodied things. So he predicted that none of those would be preserved as fossils because he had the idea, and others before.
And by the way, I have not actually been able to figure out where his citation for this, where Darwin said this. I don't know that Darwin said this. I'm not saying he didn't. I'm just saying I have not actually been pointed to this claim in Darwin, and I don't remember having read it in Darwin, but I haven't read everything Darwin ever wrote, so maybe it's in there somewhere. So.
He had the idea that the rocks form so slowly, so that the sand and the silt that's deposited to make the rock layers it happens so slowly that there's not enough sediment to bury a jellyfish for it to become a fossil. In fact, if you take today's idea, the amount of sediment is like less than the thickness of a sheet of paper per year. Right, per year.
It depends, man. There's no one universal rate of sediment deposition around the world. I'm taking a drink for... This is incredibly dumb. Different situations result in different rates of sedimentation. Sometimes you can get hundreds of feet of sedimentation in like a few days, like in a volcanic eruption. Other times you can get like a centimeter in 1,000 years, like in relatively rapid limestone deposition. And we get all sorts of rates in between. There is no single rate of deposition. Also, he is simply wrong that you need to have some kind of rapid deposition in order to preserve soft-bodied fossils. In fact, soft-bodied fossils are characteristically found in areas that have very slow deposition, but that also have other things that prevent decay, like anoxic conditions. Because the finer grain the sediment, the easier it is for it to actually preserve an impression of relatively soft tissues, which will be flattened by the weight of the overburden. And so, you need that really fine grain detail in order to make out impressions of soft-bodied animals. That's why they tend to occur in places like the Solnhofen limestone, which is extremely fine grain, or in shales, which are also extremely fine grain. And as a general rule, the finer the grain, the slower the deposition, which is actually, it might not sound intuitive, but I can explain it in a way that I think will make it pretty intuitive. So, if you've ever heard of Brownian motion, that's when, like, say you put some little crystals of salt in a glass of water, and you watch them as they fall and start to dissolve, you'll notice that they kind of bounce around. That's called Brownian motion. It's a result of the molecules of water moving around chaotically and bumping into the crystals as they fall through the water. And that's just a result of the temperature of the water. The hotter the water is, the stronger the force of the Brownian motion is. So, yeah, it's that simple. Now, one of the things that's important for, though, is it means that the lighter an object is, the more it's affected by Brownian motion relative to how much it's affected by gravity. Because remember, as it's lighter, the force of gravity pulling down is going to be lower, but the force of the Brownian motion is going to stay relatively the same, which means that the relative forces are going to favor Brownian motion the smaller a particle is. So if you drop a boulder into water, it's just going to sink, and the Brownian motion is essentially going to have no measurable impact. But if you're looking at tiny microscopic silica fragments of the exoskeleton of like single-celled phytoplankton, yeah, Brownian motion is going to be the overwhelming dominant force. And it's going to take a very long time for gravity to overcome that. And the only reason gravity even can overcome it is because gravity has a consistent vector, whereas the vector of Brownian forces are always going to be randomized, which means that there's a minor bias towards going down. Heather Schrodinger's Fossil Coon for $5 says, Grand Canyon started by Bonneville flood, maybe. Missoula floods, no way. Okay, I probably mixed up floods. Thank you very much. That is one of the reasons why I say whenever I do these live things where I don't have the time to fact check literally every statement, you should always double check. And if what I say sounds like it's off, like in that case, yeah, double check me on that. Because yeah, I will definitely mix up my paleo floods. It's a thing that happens. So anyway, that's why finer grain sediments fall more slowly. They deposit more slowly. So how is it we can get these fossils in these slow depositional environments? Well, they have to have some other factor that prevents decay too fast. And in most cases, that is actually just oxygen content. Because while there are anaerobic bacteria that will decay things, they act much, much more slowly than any aerobic bacteria or scavengers or anything like that. So this is just completely backwards.
Yeah, less than thickness of a sheet of paper per
not
year.
much at all.
How could you preserve a jellyfish? So this is Darwin's thinking, you see. So that's a prediction that no, you wouldn't find any fossil jellyfish. Well, you find lots of fossil jellyfish.
Yeah.
Jillian Flappy Ribs Wren says, how dare you not have all paleo floods exactly memorized? I know, I should retire. But I can't because my retirement fund isn't big enough. So, I don't know. Send more gifted memberships.
Wow, yeah. It makes me think about when I've gone for walks along the beach even as a kid. You know, you walk one day along the beach and you might have the winds blowing the jellyfish off the ocean. And they're all
blue bottles are the things, yeah.
blue bottles, and sometimes you
Also called Portuguese men of war. Do not touch those.
jellyfish as well, but lots of blue bottles. And they're all washed up on the shore, and you try not to step on them because sometimes they'll sting your leg. But then the next day, you know, the winds change direction, there's a bit of swell. Some of them are washed back in. Some of them are, you know, they could still be there, but you don't see them. You dig down in the sand to make a sandcastle. There's no jellyfish.
Yeah, no one is suggesting that the jellyfish preserved, the jellyfish that are preserved in the fossil record that we have, were formed on a beach one day. I can almost guarantee this guy that he's not going into, like, shallow oceanic anoxic lagoons with lime deposition. I'm just gonna take a drink for, like, well, I didn't see it at the beach. Hey, I've never actually seen a volcano erupting. Ever. At least not with my own eyes in person. You know what that's not evidence of? The non-existence of volcanoes. I do not even know how to process the degree to which that is a stupid thing for him to have said.
So it looks like you really need rapid burial, like you're saying.
No, it's literally the opposite. And the fact that this guy's life experience at the freaking beach doesn't provide him with an easy way to determine how the taphonomy of soft-bodied fossils works, like, that is not in any way an argument. That's not even a hint of a problem for taphonomy.
To really fossilize these things.
Indeed, yes. And again, Noah's flood would actually create the sediment to bury things quickly, which is why we see so many fossils.
Actually, the more swiftly things are buried, it's often the case that the less well they're preserved. Now, it is also the case that, at least for hard parts, a swift burial makes it more likely for anything to be preserved. So it's sort of a double-edged sword, right? You're likely to get more fossils if there is rapid burial, but they're going to be less well preserved, which means that more delicate organisms are even less likely to be preserved in the first place. So, if you want to find the detailed fossils of soft-bodied organisms, you need to find places where there was a very low decay rate, but also a low deposition rate, which is not a flood. Floods are violent high-energy events, which, with things like jellyfish, would tend to just shred them. Now, it's not going to shred like a sauropod, or in many cases, even like much smaller animals, like something the size of a tiger, or even a human or a wolf. But if it's jellyfish, yeah, that's just going to get shredded. You're not going to find a jellyfish fossil in a flood deposit, most likely.
What about biology? Have you got some examples of failed?
My Unfinished Journey for $6.66 says, Hail Nero, Hail Daps, and Hail Paleo Floods. Yes, even when I mix up which one is which. There are, in fact, a lot of paleo floods, which is interesting because it means that geologists know how to identify floods in the ancient past and are perfectly willing to call them floods, which is, you know, a little bit at odds with what this guy is saying.
Predictions in evolutionary biology.
There's some big ones. J.B.S. Haldane was a famous evolutionist, and
it's true. Take a drink.
Many decades ago, but he made the prediction that something like a wheel could not evolve because it would have to be pretty well perfect before it would function. So, for example, you need the whole wheel and the axle and everything has to be present for it to function as a wheel. And mutations are small accidental changes in the DNA. How could that create the instructions to make a whole wheel?
So, this is a really weird conflation of, like, separate ideas in biology. The wheel thing, I can't find any evidence of anyone ever saying that no wheels can ever occur in biology, that rotational motion is just not possible. The argument, so there is an argument about things that can't evolve, and a wheel on a macroscopic multicellular organism is an example. And the reason that a wheel essentially can't evolve is because there's no way to connect a biological wheel at a macroscopic scale to the organism which grew it such that it could stay alive itself, right? Because if it has to continue to rotate 360 degrees, any connection between it and the main body of the organism would be severed, which means they can't be part of the same organism, which means you can't realistically grow a wheel. So that's why wheels haven't evolved in things like animals, But that has never been the case at the molecular level, because you don't need physical connections that are like permanent between a molecular machine and the rest of the cell. And in fact, when this was being talked about, in fact, even when Haldane was working, we knew about rotary mechanisms in cells like flagella. I mean, this wasn't a secret. So that's one idea. Then there's Haldane's dilemma, which is basically the same thing as the waiting time, which is to say that given the stochastic nature of mutations, there's a problem in that if a particular new feature requires multiple coordinated mutations, it is extremely unlikely for all of those mutations to happen in any realistic amount of time in a single lineage. And that is, in fact, a dilemma that was solved about the same time that Haldane mentioned it. But also importantly, it's not a damn prediction. It was a dilemma posed because he noticed an area where the math that he was using in population genetics seemed not to align with actual observation. So it was presented as a paradox, not as a prediction. Minigeeky says, could a colony of organisms evolve a wheel? I would argue that they already have. There are ant colonies that basically form exterior colonies. They don't like burrow into the ground. And they are capable of rolling up into basically a ball in order to do things like move. So there are ants that basically function as wheels. So yeah. There are essentially biological wheels in that sense. So the Haldane's dilemma was about this waiting time. Now it turns out that the solution to Haldane's dilemma is in asexual organisms. It's just horizontal gene transfer, right? Like bacteria share plasmids between each other, which can get mutations from one group to the other, and it can combine separate mutations, which together provide a selective advantage. And in multicellular complex organisms like humans or Ceratosaurus, it's solved by crossover and sexual reproduction, which again can help coordinate this. Now, in order to try to resurrect Haldane's dilemma, creationists will do things like ignore the fact that evolution is not seeking specific solutions, vastly underestimate the functional sequence space available in, the functional part of sequence space that's available for DNA, which means basically if you have a chunk of DNA of this size, how many different arrangements of that DNA, how many different codes in that DNA could result in some kind of functional property. They vastly underestimate the functional fraction of sequence space. And they then ignore crossover. In fact, in waiting time papers from people like creationist geneticists like Sanford or Carter, they will actually include in their papers things to the effect that we do not expect crossover to be a significant factor, when it's actually the thing that solves Haldane's dilemma. So none of this is even a prediction in the first place, and he's conflating separate separate former problems in evolutionary biology. And this is a very chaotic part of the video. I don't actually know what is in his brain. There's also cartwheeling animals like certain desert spider. So there is that. Whole organisms, in other words, can rotate. Whole macroscopic organisms can rotate. But what can't evolve is an organism that has, as part of its anatomy, a wheel. At least if it's a macroscopic multicellular organism. A madman says, at what point does a log become a wheel? I would say that it becomes a wheel when it is, one, more narrow than basically the height of the cylinder is lower than the radius of the cylinder, and when it has an axle that something else can be attached to. At that point, it becomes a wheel. In my book. If you have a different definition, that's fine.
With the axle and everything, it wouldn't happen. So he made a prediction you would never find something like a wheel in a living thing. Well, we've found things much more sophisticated than wheels, like even rotary motors.
Wow.
So the ATP synthase,
ATP synthase, flagella. So ATP synthase, as far as I know, was not discovered when J.B. Haldane was, or J.S., whatever, doesn't matter. Haldane was working. But flagellar motors were. Now, we didn't know exactly how they worked, but we knew they rotated. And no point was this whole wheel thing about microscopic, like subcellular machinery. It was always about macroscopic organisms.
Sounds complex, but it's basically an electric rotary motor in all living things. And this is a major fail for this prediction.
Which again, wasn't even a prediction, and he's mixing up two things. I'm taking a drink. Baba Ali says, I think a log becomes a wheel when someone wants to use it as a wheel. Okay. I mean, so it does raise the question, like, is the roller on, like, a steamroller? Like, you know, something that's supposed to, like, flatten out a terrain? Is that a wheel? And, like, I guess you could say it's a wheel. I don't know. I probably wouldn't use that word. But I would call them log rollers at that point if they were too... a large section of the log was in use, such it was very long compared to its diameter. But, hey, like I said, that's my personal definition. You can have another one, and that's perfectly fine.
It also, they're not just rotary motors. There are linear motors, like when we move our muscles, there are little linear motors that pull on the fibers in our cells and things to make the muscles contract and so on. And there's just motors that are involved in unwinding our DNA so it can be copied. And these are absolutely essential for life. And he said they couldn't evolve.
Muscle fibers are absolutely not essential for life. It's also not entirely clear that ATP synthase is either, because we can get reproducing chemical systems that don't require ATP fairly easily in labs. So.
Wow.
He also predicted that something like a magnet would not evolve because, again...
I've never seen anyone making this claim that a magnet wouldn't evolve, but also you can't just evolve a magnet. You can incorporate magnetic materials into your biology, and then you can evolve sensory organs which interact with those magnetic materials, but that's not the same thing as, like, evolving a biological magnet. That's not a matter of evolution having a problem, that's just, like, the kinds of material life is made of being a problem.
What would be the point of having a magnet unless you had the paraphernalia there to be able to measure the forces on the magnet and to actually use it? Well, birds have magnets in their brains that help them navigate. Even bacteria have magnets. Some of the bacteria have magnets that help them orientate themselves.
Okay, so what does a magnet do? It feels a force in the presence of other magnetic fields. So if you have a permanent magnet in your body, what apparatus is necessary for you to sense that? Just pressure sensors, that's it. And your body is full of nerves that sense various things like pressure, temperature, and such. So this is not exactly a huge leap. And organisms routinely ingest things that have limited magnetic properties. Things high in iron and whatnot. Which means it's not actually that big of a stretch to concentrate such things in a part of your body that has pressure sensors. Like, there's not actually some kind of problem for evolution. And it was not a prediction that these kinds of organs couldn't evolve that I've been able to find. And also, one of the things you'll notice is that when he says that these were predictions, he doesn't actually give us a citation for where they were predicted. At most, he just tells us the name of a famous scientist who allegedly made the prediction. And in some cases, he's wrong about that. It's just a little curious that we don't actually get that information.
Another big fail. So these are strong predictions by a very famous evolutionists, and they're big failures.
Yeah, it reminds me.
Wait, it's JBS Haldane. That's why I can't figure out if I should say JS or JB, because it's all of them. It's JBS. Sorry, Mr. Haldane from Beyond the Grave.
When I was doing engineering studies, we had this team project.
Oh, he's an engineer. It's not an official drink figure. We're going to drink for it anyway. The general rule of thumb, anytime you come across a creationist claiming to have STEM credentials, it's almost always an engineer.
We had to build a minesweeper robot, and one of the things I had to work on was the magnetic detection sensor, and the amount of design we put into that, and the iterations and failures, and it took a long time to get it just right. And we've got these creatures, you're saying, who have got magnetic sensors in the way that they pick up tiny signals. That's just the sign of design. Like that's amazing.
No, you have to argue for it being a sign of design, because we know of ways that biological populations can gain features that does not require design. So to claim that this particular thing has to be designed you have to do more than marvel at how cool it is. Because nothing about coolness implies design.
Amazing.
Yeah, amazing design.
Yeah, so you're saying there's quite a lot. You said 40 predictions that have failed in evolution, and your field is biology. So what's your favorite failed prediction in biology?
The favorite one would be junk DNA. This again was a...
We're going to take a preemptive drink for this one, because we all know where this is going. All right, Vadim Radchenko says, are you calling for a new Council of Nicaea to introduce the new rule? Well, first, I am not in a position to call for an ecumenical council. Not at all. Second, I do believe that... so there... In the Eastern Orthodox Church, they've been working on a new council that has rumblings of being taken as a new ecumenical council, and that's been in the process for like 20 years. In the Roman Catholic Church, I mean, those guys, I feel like they hold an ecumenical council like, every few decades. So there's that. But no, I am not calling for an ecumenical council. I am not someone who has such standing. My Unfinished Sock for $2 says, I correctly predicted my sock would like and share. Well, thank you very much. I appreciate your sock doing so. I have just now ran out of my initial drink, and it is a little bit past the it's a little bit past the top of the hour. So, I'm going to take a quick intermission. I will be back, hopefully very shortly, and then we will continue on. I will get myself a second Baja Blast. So, in the meantime, please enjoy the musical stylings of one Bent Hovend. Okay, I am back, I suppose. Thank you for sticking with me. Actually, I think we grew in viewership. One thing I want to say before we get right back into it is the quick little how to support the channel bit. So this channel is almost entirely dependent on the support of my viewers. The ad revenue that comes in from YouTube just from ads is abysmal. So if you are enjoying this channel, the streams, the scripted videos, all that stuff, I would encourage you, if you can afford it, to consider supporting financially. The easiest ways are with Patreon or the channel memberships. Patreon starts at $1 a month. Channel memberships start at $1.99 a month. You can get a 15% discount on Patreon for pledging annually. Both of those give you access to my Discord server. They also both give you access to early access to videos. And I think we have a pretty cool community over there on the Discord server. There's also, if an annual or monthly pledge isn't your thing, we have a merch store. There's a merch shelf right below this video. You can take a look at that. You can also click through if none of that interests you. There's more stuff that I can't fit on the merch shelf. So, check out the merch store. I also have a Amazon wish list linked in the description. Also, Bent Hoven, my regular co-host for Kent with Bent, has a wish list and a Patreon in the description. You can get him some stuff there. And of course, if you are generous enough today, we might get Bent a free pizza. We're pretty far away from it, but we could do it. We have to get to 100%. But if we get there, Bent gets free pizza. So, and whether or not you can afford to support financially, please do like the video, share the video with some people you think might enjoy it, comment on this, and also Joshua Geese has just gifted 5 Dapper Dinosaur memberships. So, let's take some drinks for that. Here we go. 1, 2, 3, 4, and 5. Vinny Renchico says, does Dr. Kip get a maple syrup list? I don't know. That's up to him. I don't actually know if he has a wish list linked on his channel. I know I finally got Jackson Wheat to add a wish list to his channel, and he almost immediately got something from it. So it does work. And I really do appreciate when people get me stuff from a wish list. It's full of stuff that is basically just going to make me happy, which I got to tell you, not a lot of the stuff on there does not look like it directly contributes to video production, because a lot of it's stuff like, books or stuff like that. But here's the other thing. Getting that stuff really helps prevent burnout, right? So, because one of the biggest things about YouTube is it is super easy to get burnt out, because it is just a hamster wheel of video and content production. There is no end to it. There's no point where you're just like, well, there's nothing else I can do. And it is so easy to throw yourself into it head first and be consumed by it and then burn out quick. And the wish list is actually a major way that I help stave off burnout, because it is a constant looming threat that I might have just burn out sometime and just be unable to effectively create videos. So it is much, much more important than you might think, even with the stuff that is not directly related to video production. So, all right, here we go.
Strong prediction from evolutionary biology. And the idea is that there must be lots of DNA in our cells that has no function. It's junk, leftovers of evolution.
And there, in fact, verifiably is, but we'll get there.
So where'd that idea come from? Well, first of all, they recognize there are lots of mutations happening, and they recognize that they are largely slightly bad, so they're not helping us. Most of the mutations are...
Most of them are actually neutral, but more of them are bad than helpful in most circumstances.
Harmful, but slightly harmful. So if all these mutations were happening and they're slightly harmful, then we can't be evolving. We have to be going backwards. We must be heading for extinction.
That is not true. That is the genetic entropy nonsense. So it's extremely dumb. We're going to take a sip of our drink here and talk about it. So what actually is the case is that if it were actually the case that most mutations were harmful, then what would actually happen is that as creatures pass a threshold where that harmful mutation is actually now creating an effect to their reproductive output that is within the realm of possibility for evolution to select or to act upon, that particular genotype will be eliminated, and those creatures that are, just by chance, not so affected by negative mutations will then form the basis of the gene pool and will then continue to go on. And certain members of the population will always fall into that selection zone where that particular genome is eliminated. But it won't be all of them, because it mathematically can't be. This is one of those rare cases where there's a topic in science where I can say that we have absolute proof that this does not work. And that's because it is based on math. And the math just doesn't math. you have to make math errors in order to do this. You have to assume things about the math of population genetics that just isn't true. And so this is once again one of those places where creationists just don't actually have the evidence that they think they do. Sure, they write papers about this. In fact, some of these papers have even managed to get into real journals. But the problem is that, yeah, they can't do their math right. Because once you do the math in a way that actually models the real world, the entirety of genetic entropy just kind of disappears. It's not a real thing, except, ironically, in extremely small populations, which is the opposite of what genetic entropy is supposed to be about. Genetic entropy is supposed to be about the more mutations you have, therefore, by definition, the more genetically diverse you are, the less healthy the population is. But we actually know that the only time that mutations tend to lead a population towards extinction is when the population size is extremely small, meaning that they have extremely low genetic diversity. So, ironically, it's literally the opposite of what creationists think is going on. Which is just, I think that particular thing is just chef kiss perfect. That the only time anything even remotely approaching genetic entropy can be observed, it's in genetically homogeneous, not genetically diverse populations.
So they made a prediction that 98% of the human DNA must be junk.
Actually, I don't remember anyone ever saying 98%. That is not a thing. So let's take a drink because I actually know where that number comes from. So that number is actually the inverse of the percent of DNA that was estimated to be protein coding. But no one at any time has ever thought that the genome was divided into protein coding and junk. We've always known that there were other parts of the genome doing other things, like regulatory regions, promoters, developmental genes, things like this. These have always been known to be parts that are not necessarily directly coding a protein, but that are in fact very functional. So whenever any creationist tells you that the prediction was 98% junk, they either don't know what they're talking about, or they're just lying. Those are the only options. Wayne Rossi says, new drink trigger, congratulations, you debunked orthogenesis. With the Godzilla, thank you very much. Let me add that in to our running total of stream donations. There we go. 30% of the way there, we could do it. We still need 70%. But we could get Bent that free pizza. And I feel like Bent might waste away, so, you know.
Okay.
Right, because if 98% of these bad mutations are happening in the junk, then there's a possibility that we can avoid this extinction problem from the mutations.
So that there was an idea that junk DNA was in large part a buffer for what would otherwise be deleterious mutations. However, while that is something that it is still talked about and it is still a valid idea, it is also the case that it turns out that the maximum functional fraction that a population like humans could persist with is actually very, very high. Humans could survive without noticeable effects to their fitness, with the vast majority of their DNA being functional. Now, it turns out that that's not the case. They don't do that. But yeah, this was actually Dan Grauer was the one who initially did the math on the maximum functional fraction that could be sustained in terms of evolution. And he came up with a very high non-functional requirement, so a very low maximum functional fraction. But later on, other papers were written in opposition to his paper making that claim, and Dan Grauer actually accepted the newer results and admitted to having made errors in his initial paper, and no longer stands by that initial paper. So all of that just stems back to Dan Grauer's initial paper about functional fraction in the human genome, and even he now says that he was wrong about that. So there you go.
So is this a bit like having a garage where you can do all your experiments and work things out, and then eventually go to production and sell it later?
Well, this is another angle. Another reason why they predicted junk DNA was that they said that if evolution was to progress, there must be lots of DNA available where we can have experiments going on with mutations. And yeah, it's like a sort of playground for evolution. There has to be lots of junk DNA to play around and make new functions. So.
And we actually know experimentally that this is verifiably the case, even if young Earth creationism is true. And the way that we know this is because there is such a thing as a species-specific orphan gene, right? So remember, creationists think that kinds are bigger than the species, right? They usually say that the kinds are roughly around the family level. Well, within families are genera and species, which means that if there are orphan genes, which means taxonomically restricted genes that do not have homologs outside of that taxonomic group, at the species level, then it means that within kinds, you can have new genes evolve. We have such things, which means that there must be a source of genetic code that can be neo-functionalized or given function that is not already functional in the wider ancestral group. And if anything bigger than species is going to be our definition for kind, then I'm sorry, but that means that it is the inescapable fact, even if young Earth creationism is true, that there is a such thing as junk DNA, and it can be neo-functionalized into a new gene. Let's see. Cadence Linker says, once the script is complete, would you like me to send it to you for you to read? Feel free. I don't know when I will get around to it. I don't want to make promises there because, as it has already been said, I am in fact a busy dinosaur, and it, like even on my quote-unquote days off, there's still usually a lot of stuff that I'm doing that I kind of have to do. Like, for instance, this weekend is going to be mostly focused on getting a teaser trailer ready for the next episode of Star Trek Lexington, my actual play series over on Top Hats Off. And like right now, I have some of the assets done. I have the alien creature that was going to be featured done. I have a phaser turret model done. I have some landscaping stuff done. But there's still a lot that needs to be done. I still need to record my audio. I need to edit Jordan's audio. So like, even my quote-unquote days off, it just means time to work on projects that aren't Dapper Dinosaur. So, yeah, I have no idea when I'll get around to reading it. But yeah, sure, feel free to send it over to me. So there you go.
So that was the second reason. And there was a third reason for the prediction, and that is that evolution is a messy process because it involves these accidental changes, mutations, and mutations would not be expected to create 100% functionality.
Yeah, actually, he's right about that. That is a good reason why we should expect junk DNA, so I'll take a drink for that. And remember, that's true under young Earth creationism as well. So young Earth creationists should also predict there be junk DNA. Now, they have, I would think, fair reasons to predict a much lower amount of junk DNA than evolution, which, to be fair, they do predict. But they should still predict there would be some junk DNA.
In fact, most of it would be pretty rubbishy. And so
there is a difference between garbage and junk DNA. Garbage DNA is actually stuff that is somewhat harmful, whereas junk DNA is just kind of neutrally there. And I don't know when he says rubbish DNA exactly what he means. He might mean garbage. He might mean junk. I'm going to just presume that we're focusing on junk. So
there were three strong reasons why the evolutionists predicted lots of junk DNA.
Mm-hmm.
Right.
It's a big fail.
It's really not.
The ENCODE project, which
every single time creationists bring up junk DNA, they bring up ENCODE, and they bring up the 2012 conclusion from ENCODE. I can almost guarantee you that that's what we're going to get. But also, Danthaman Crow has just joined the channel at the tetrapod level. Everyone, send some tetrapod emojis and maybe some sessile tunicate emojis to welcome. It might be Dan the Man rather than Dan the Man, so sorry about that. I'm going to go with Dan the Man unless you correct me. So welcome Dan the Man Crow to the channel memberships. So thank you very much, Dan the Man. I really do appreciate it. And if you have trouble getting into the Discord server, please do let me know. I'm probably easiest to contact, ironically, on Discord or on Blue Sky. I will put my Blue Sky username in here in case anyone doesn't have it, because if you have a Blue Sky, you should totally follow me, because I basically don't check Twitter anymore. My Twitter account does still exist, and I do log into it once or twice a week, but I am no longer primarily using it. The science friends have moved over to WhatsApp for our group chat, as well as Discord, and that was the only reason I was still really active on Twitter, was because the science friends group chat was there. Now that it's not there, I almost never go back to Twitter. So yeah, follow me on Blue Sky if you really want to keep up with what I'm doing outside of YouTube. So yeah. Anyway, here we go.
Involves scientists from all around the world in many labs published major reports about 10 years ago where they looked at all the DNA and looked at whether it did something. And they found that over 80% of the DNA had some function. Didn't identify what the function was, but just it had some function.
Okay, so ironically, he's actually given a reasonably good description of what they did, which means I'm going to take like a double drink because one, what he's saying is extremely stupid, but two, he's also kind of technically right. So when he says does something, he's absolutely right. But what something is basically anything. It was any biochemical activity other than being duplicated in like reproductive events. Let's see. April Van Ryn says it's called X now because it wants you to break up with it. I will continue to dead name Twitter while Elon Musk continues to dead name his trans child. That's my policy on that one. If Musk feels upset about me calling his website something it doesn't want to be called anymore, I'll just point out that he does that same thing to one of his children. So yeah, when Musk can figure out how to address his kid, I'll figure out how to address his website. And then Jillian Flappy Ribs Wren says, you mean you're not sticking around on the toxic cesspool full of bots? Yeah, no, surprisingly, I'm not. My plan is to probably deactivate my account sometime in 2025. Basically, the only thing I use it for now is occasionally I'll actually post that I'm going live, or I'll share a post that says I'm going live. Which also means if you want me to be aware of something, don't share it with me on X. Share it with me on or Twitter. Sorry, share it with me on Blue Sky. Yeah. So I've been on Blue Sky for a while now, since before you could just join it randomly. So there you go. Go over there. You now no longer need an invite to join Blue Sky, which you did back when I was first going. And there's Mothra again, so we'll take a drink for Mothra. Metagigi Platypus Monk Princess sends 5 trans flags and says thank you, Dapper. And then Triceratops also sends 5 trans flags. Yeah, I mean, look, you don't even have to be a trans ally to get the fact that calling people what they want to be called is the bare minimum of decency that you should show people. Right? Like, if you come up to someone and they say, like, hey, my name's Tom, but you think they look more like a Diane, that's not a good reason to not call them Tom. Call people what they want to be called, unless it's, like, actively an attempt to, like, be bigoted, right? Like, unless they're going to go, like, oh, give you the name of, like, you know, the mustache man from the Second World War or something, you should generally call people what they want to be called. It's the minimum of decency. Even if you think it's a ridiculous thing to call them. And if someone is taking advantage of that fact, that's the person who's the asshole. Not you for bothering to just have that minimum amount of, you know, give a shit about other people.
And so, in fact, the spokesperson for that project, Dr. Ewan Burney, said he expected the number would rise to near 100%.
Okay, right. I had to refresh my memory as to what we were actually talking about when we got tracked into, like, how shitty it is that Elon Musk dead names his own kid. So we were talking about the functional fraction and what it is that encode means by function. Encode had any biological activity that is not duplication or, you know, transcription in the case of, you know, whole genome copying as function. But here's the thing. That is the same idea as me saying, okay, so let's say you have one of those glass-fronted cabinets, right? And it's full of little ceramic figurines that your grandma collected. And your grandma, say, well, in this case, in this hypothetical scenario, has passed on a while ago. You inherited this thing. You don't really know what to do with it. You don't really care that much, but it feels weird to just get rid of it because it feels like you're kind of getting rid of a part of grandma. And so you don't get rid of it, but you don't really look at this cabinet, and maybe it's in an out-of-the-way room, or maybe it's down in the basement or up in the attic or something. And what happens is that all of these little ceramic figurines start accumulating dust. Encode would say, those figurines are a functional part of your life, and their function is a place for you to store dust because they're accumulating dust. That's what they're for. They are functional dust accumulators. Most people would say that that is completely absurd and that you have no particular need for the collection of dust. It's just a kind of thing that happens regardless of whether or not you want it to. Or similarly, if you have, say, a set of shoes and they occasionally get gum stuck to them, ENCODE would say at least one of the functions of your shoes is to stick gum on. Well, no, in fact, the fact that that happens is actually something you would rather not happen, but you don't have a great way of preventing it perfectly, so it happens anyway. The actual function of your shoes is to do things like protect the soles of your feet when you're walking. But the fact that they just kind of also do another thing that you would rather they not do is an indication that that's one of their functions. So ENCODE used this biological activity definition for function that no one but ENCODE has ever accepted. And that was what they used in their 2012 paper, where they said that there was approximately 80% functionality in the genome. In 2014, 2 years later, the same group of authors, with a few changes because of who was working at ENCODE, retracted that, changed their definition, and now it's basically the reverse. They say that the genome was about 80% junk. ENCODE does. So there is no one, even ENCODE, still making the claim that the vast majority of the genome is functional. Because it's obviously not. One of the ways it's obvious is we can tell which parts of the genome are under selection pressure, under what's called purifying selection, which means that the sequence of that part of the DNA is important, which is why it's preserved. So it accumulates mutations at a slower rate than other parts of the DNA. And so we can actually measure the rate of accumulation of mutations in parts of the DNA that are neutral, that are junk, right? Because it's just going to be the overall phylogenetic replacement rate, which can and has been measured. So basically, you just take samples from significantly distant ancestor-descendant relationships, right? So you want to go as many generations as possible and compare the DNA and compare how many mutations have accumulated from one generation to the distant generation. And you will find a rate, and that rate can then be used to figure out what's junk and what's not, because parts of the genome that accumulate mutations at a significantly slower rate are doing so for no other reason than because them differing tends to be deleterious, which means that they tend not to accumulate mutations, because mutations that occur tend to be selected against. And we can find that the majority of the genome is in fact not under purifying selection, which means it's not sequence constrained, which means that it is incapable of performing the vast majority of functions that we know that exist. Which means that, and we know that in most cases it's not performing the other functions because of things like knockout tests. Which means that whether or not something is junk isn't just that we don't know what it does. We can know positively that it is junk. Because we can tell. There are ways to measure this. Junk is not just the default condition for DNA. We don't just assume that as long as we don't know what it does, it must be junk. Because there are also parts of the DNA that are under purifying selection that we don't know why. We don't know what they do. But we don't label them as junk because if they were junk, they wouldn't be under purifying selection. Cheery words of a king 7 times purified Rana says, but Dapper Dinosaur, obviously ENCODE was right when they said something that was good for young Earth creationists, and now they've changed their opinion. They're absolutely wrong. Of course. Yes, of course. Also, interestingly, their biggest critic in this was the aforementioned Dan Grauer, who was wrong about the maximum functional fraction of DNA in a human genome, but who was right that ENCODE was wrong.
Wow, that's a lot.
It is a lot, random guy who I don't remember your name. If anyone remembers this guy's name, let me know. I will give him this. He is he's better at this than Trey Hutchins from ICR. I think Trey is like the worst of the creationist vlog hosts. He's really not good at it. This guy is doing a better job. He at least seems somewhat enthusiastic about it.
A lot of function.
So compared to 98% junk,
which again was never the prediction. That was the non-coding portion of the DNA, which has never been synonymous with junk.
It becomes at least 80% functional.
Nope, it's closer to 20, according to ENCODE themselves.
Yeah.
And some of the evolutionists came out all guns blazing against the ENCODE project. They said
And then ENCODE agreed with them.
Can't possibly be. This can't possibly be, because evolution says this.
Take a drink. Okay. And they were right. They made a prediction on the basis of the theory of evolution, and they were so right that even ENCODE had to agree with them in the end. This is the exact opposite of a failed prediction. This is a confirmed prediction. And then when someone said, nope, we think you made a mistake on this, and they doubled down and said, no, we're much more confident in the theory of evolution than we are in your paper. And it turns out that, yeah, the theory of evolution got this one right. So while it's true, it's not proof of evolution, it's certainly evidence in the evolution bucket, and it's disconfirmation of creationism if creationism makes the contrary prediction.
Well, evolution didn't happen.
Yeah. Now, some of our audience might be saying, oh, look, that's all well and good to poke holes in evolutionary theory and look at their failed predictions.
Which there haven't been any of. Not a single prediction made by evolution that has failed has been pointed out by this guy. He pointed out a problem with models of galaxy formation. That was the only thing that he's pointed out that was a failed prediction. That's it. Everything else has either not been a prediction, hasn't failed, or it's not been associated with evolution.
But the creationists, they don't even have any predictions. Is that the case?
No, actually, creationists have predictions. They just routinely turn out to be false when they contradict the predictions of evolution.
Well, just about all of those evolution predictions have a flip side. In fact, many of them are motivated to counter creationist expectations. For example, one of them is the idea of vestigial organs, which is the idea that we have lots of organs in our bodies which are left over from our evolutionary ancestry, which have no function.
Nope. No function is not a requirement of vestigiality. Let's take another drink. Jeez. Vestiges, or vestigial organs, are organs which no longer function for the primary purpose for which that organ has evolved and which it is still used for by any more basal members of that same lineage. So, for instance, you could make the argument that your jaws are vestigial gills. Why? Well, because while they're very, very functional for food acquisition and food processing, they're really, really crap at extracting oxygen out of the water. Similarly, while it is the case that many humans can move their ears a bit, their muscles on the ear are vestigial because they no longer assist in determining the direction from which sound came. Not a thing they can do anymore. And yeah, I just pointed out the muscles thing, Vadim Marchenko. Similarly, while the hips of whales might be very important for whale reproduction, they are completely useless at supporting the creature's weight, which makes them vestigial. Another one is, while the spurs of a python might be useful in maneuvering a mate so that copulation can occur, they're really, really, really bad at supporting the animal's weight or helping it move, which means they're vestigial legs. Vestigial does not mean functionless. The fact that you can find a function for an organ doesn't make it not vestigial. And the fact that something's vestigial doesn't mean it doesn't have a purpose or a function.
And the appendixes and the tonsils, for example, are often held up this way, but they're not.
The appendix is probably not vestigial. It looks... So for a very long time, it was thought to be homologous with the vermiform cecum and many other animals, including things like ungulates and whatnot. It seems that that's probably not the case, and it seems like it actually may well have evolved for its current immune functions, as well as a reserve for a healthy gut bacterial sample. So the appendix is probably not there. Now the tonsils, on the other hand, do still have limited amounts of function for their original purpose, but they barely help with that. Basically, they're supposed to help you prevent infections from inhaled pathogens. But they're really, really crap at doing that. They do it a little bit. People without their tonsils do have a slightly higher infection rate from inhaled microbes and whatnot. But it's extremely minor, so they're sort of like in a weird zone where they do technically still perform their original function. They're just bad at it. So that's one of those things where, like, is it vestigial? I don't know. I probably wouldn't say so, but, like, if you did, I'd get it. So. An intrigued feline says, fun fact, one of the ear muscles in my ear is now being used as an eardrum replacement. Interesting. Okay. I did not know that was a thing. I would be interested to look more into that and like how that procedure works and whatnot. Sounds interesting. Yeah.
Not without function. That's another story. So the evolution prediction was the flip side of a creationist expectation that God wouldn't create us with lots of junky stuff in us.
Okay. Explain ear muscles or erector pili muscles, the things that give you goosebumps. What the heck are those for? Explain the extreme awfulness of the human spine. Explain the extreme awfulness of the coccyx. You know what happens if you break your coccyx? Horrible. Those muscles don't need to attach to the coccyx. The coccyx could just not develop, and those muscles could just attach to like the medial side of like the iliac, or the ilium. Sorry. Like, this is. If God didn't design humans with a bunch of junky crap in them, you and I must have very different definitions of junky stuff there, Mr. Don. Was it Don Batten? Which is weird, because he actually looks very different in the pictures that I found of him. I guess he just aged more, but I don't know. They barely look like the same guy to me. Including in this thumbnail.
So the flip side of the evolution prediction is actually a reaction to a creationist expectation with the objective of proving that we weren't created, but we evolved.
No. Oh my goodness. I'm going to take a drink. Basically, nothing in science ever happens as a reaction to anything in creationism. And here's why. Scientists don't give a fuck about creationism. They just don't care. Creationists aren't having the discussion that could make science care. They're not, by and large, publishing in actual journals. They're not going to the conferences. They're not presenting their ideas. They're not even presenting their ideas as posters at conferences for the most part. Right? Like the bare minimum that you could do to get professionals in a field to interact with you in a science field is to go to the conventions that they have and like bring a poster with your ideas. Have the conversation. Creationists don't even do that. They stay in their little insular bubbles for the most part. They only publish their weakest versions of their conclusions in real journals, and those are usually, anyway, shot down and often retracted anyway, because they're usually atrocious. Or they stay up and are good work, but that just, don't actually support any distinctive beliefs of young Earth creationism. So, creationists matter to real science the same way that flat earthers matter to NASA. Flat earthers will always go around saying, like, well, how come NASA's not doing anything to show us that the Earth is a globe? And the answer is twofold. One, I mean, they are. You're just way too skeptical to take it seriously. And two, they barely even know you exist and they don't care about you. All of the principles of science that are at odds with young Earth creationism at this point have been so well established that the idea that anyone is trying to still demonstrate them is crazy. No one is trying to demonstrate evolution. That was already done over a century ago. We've moved on. Silu, just for 50 secs, which thank you very much, I do appreciate when I get the sec, says, everything was created perfect by God, but is less perfect now because of the fall, because creationists want it both ways. Yeah, that is a little convenient for them, right? They can just say, oh, well, all the problems in biology, that's the fall. All the good stuff, that's God. Like, oh, that's handy. That might be a thing you can say in terms of, like, your personal theology, but, like, that's not a principle that's useful in science. So, here we go.
So virtually all of the evolution predictions have a flip side, which is a creationist expectation, quite different. Now, my colleague, Dr. Carl Whelan, back in 1994, made the prediction that most of the human DNA would be functional.
And he was wrong. Very, very, very wrong. Now, I do know that it is 1:58, which is normally the time that I would be wrapping up. But here's the thing. I don't want to. I've still got a whole lot of this Baja Blast here. And I also want to give us still a little bit more chance to get Ben Hovind a free pizza, because the dude is hungry. So, what we're going to keep going. And we will stop when this guy runs out of stuff to talk about, or when I run out of things to drink, or when we hit, 2 p.m. my time. Whichever of those things happens first, that's when we'll stop. So, here we go into hour 3 of Dapper Reacts.
He said, because we live in a fallen world where human sin and rebellion against God means that he's withdrawn some of his sustaining power from the creation.
Literally, here it is. Creationism predicts everything should be perfect. Oh, it's not perfect? Well, I guess that's that darn sin. Convenient.
There would be some non-functional DNA, some damaged DNA, but not very much. And so he made a prediction.
Wait, Siluth, you can't order pizza at 2200? What? I'm not going to recommend that you move to America, but I will say one of the things that I like about America is that, it's almost never too late to order food. So, sorry about that.
And that real science would actually find the function of the DNA, and that's what's happened. It's proven correct.
It is hard for me to express the degree to which that is just not true. I'm going to take a drink. It's absurd. All right, here we go.
And so that's one. There are many others. For example, in geology, creationist geologists predicted that the diffusion rate of helium in zircons would be 100,000 times what the evolutionists said it was, based on their belief that the Earth is only 6,000 years old. And guess who was right?
The creationists?
Yeah, they sent it off to the lab, and a couple of years later got the result back, and the creationists were correct.
I really hate zircon helium diffusion. For one thing, it's just incredibly boring to me. Whenever I have to talk about it, I feel like I'm about to go die of boredom. But an intrigued feline says, even in small towns at Dapper, it depends on how small the town is, honestly. Yeah, that's to be fair. Which also means, I don't actually know if Siloof is living in a city or in some rural town, so it may not in fact be a country difference. But Josh Boogie's just gifted 10 Dapper Dinosaur memberships. Thank you so much. Let's take 10 drinks. I was going to say 5, but that's obviously wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, which is also giving me a little bit of brain freezy feeling. Ooh, that's not great. Okay. I lost my train of thought. I'm going to listen a little bit more and we'll get back onto it.
Another one. A creationist predicted that diamonds would contain carbon-14.
Oh, right. Helium diffusion. Here's the thing. The way this is measured is by taking a look at starting helium and ending helium. And then the creationists just assume that is how much helium was lost. But you can also just measure how much helium actually comes off of things if you stick a zircon in a vacuum chamber. The problem that most of their helium diffusion rates ignore, or actually what they complain about, is they say, okay, helium is diffusing out of this crystal faster than so fast that we could not have ancient zircon crystals, which is what we get when we radiometrically date them. The problem is, of course, is that helium is just a alpha particle with electrons, and the zircons are full of alpha emitters. So there are sources of helium in the zircons. So, yeah, it's not actually a problem. It's literally made up for by new helium entering the zircons as a result of alpha decay. That's it. That's the whole solution. Let's see. I've got a couple things. Vadim Rychenko, will this evolution expert babble about polonium halos too? I don't think so, but maybe. Chris McDaniel says, drove through Arizona a couple weeks ago and waved in all directions in the middle of the state and said, hi, Dapper, beautiful state. If you were in the middle of the state, I was south of you. Because I live in the Tucson area. But I do appreciate it, and thank you very much. And then Triceratops Australia. Triceratops Australia is some Latin guy. Oh yeah, from Kent. So Triceratops Australia, some Latin guy says, for $2 for my birthday, I'm giving to Bent's Pizza Fund with a Mothra, and we will take a drink for the Mothra. Thank you very much, Triceratops. That will get us ever so closer to Bent getting free pizza, so that he has the strength to continue on and do another Kent with Bent at the beginning of next month. Which, by the way, we will have to talk about because the schedule of streams is changing slightly because December 24th, which is Christmas Eve for most people, is on a Tuesday, which does mess up with a few things. So we're going to talk about how that's going to work on December. Don't worry, you are going to get as many shows at least as you expect, even on the days that you expect them. Just exactly which show you get on which day may change a bit.
Okay.
Now, diamonds are supposed to be billions of years old, and they couldn't possibly have any carbon-14 present if they were billions of years old.
Wrong! Radiogenic carbon-14 can in fact occur in a diamond underground because the underground is full of radiation, which means that nitrogen-14 impurities in a diamond can in fact become carbon-14 impurities in the same way that nitrogen-14 in the air can become carbon-14. Now, it's going to be less likely, which is one of the reasons why you get relatively old ages, but also, I didn't just pre-record it Intrigued Feline, it's going to be live stuff. Don't worry, I'm going to explain it. Anyway, there's another problem, which is to say that you can't actually guarantee that there is actually any carbon-14 in these diamonds. Because one of the quirks about this whole diamond carbon-14 thing is that every time creationists have these diamonds carbon-14 tested, they all come back with like the maximum carbon age that you can possibly get. And the reason for this is that there's no way to perfectly evacuate the test chamber, right? So the way that carbon dating works is you take your sample, usually, if it's not pure carbon, which most samples aren't, you actually have to burn away everything that isn't the carbon. You crush that up, and then you put it into the mass spectrometer, which vaporizes the carbon and then can be used to give you the isotope ratio. Okay, but then what happens? Well, now there's a bunch of carbon vapor in the test chamber, which gets pumped out. And then what solids are left are removed, and a new sample can be put in. But that pump is never going to be perfect. And so even if you put in a sample that has 0 carbon in it, right? You put in like a crushed up bit of like 0.999 fine gold in there, and you're going to get a radiocarbon age. Why? Because there is going to be residual carbon vapor in the test chamber, no matter what. So, creationists have not actually verifiably detected carbon-14 in diamonds in the first place. Also, some of them have just used beta decay tests, which don't actually show you how much carbon-14 there is. It's just a reasonable proxy in some cases. But if that sample has any other things that beta decay, well, it's going to get pinged on that. But even when they're actually measuring for carbon-14, they can't actually say they've detected it because they've always detected it at levels that are essentially identical with what happens when you put in a calibration sample. A sample that we have good reason to think just doesn't have any carbon-14 in it, that we're using as our 0 points. Oh, there's Mothra again. It's busy today. Thank you very much, Mothra. So, yeah, there's numerous reasons why this whole thing is just nonsense. So, have creationists found carbon-14 in diamonds? No, but there almost certainly is small amounts.
Because you can't put carbon-14 into a diamond after it's made.
Right.
You can't put it in there, but you can transform nitrogen-14 that's already in there as an impurity into carbon-14. So there's that.
Right.
There's all the crystal structures full. So guess what? Diamonds do have carbon-14 in them.
Right.
You actually haven't demonstrated that, but they probably do.
Right. Wow.
Another prediction, that if you take all the coal samples across hundreds of millions of years and you look at them, you would find that the same amount of carbon-14 present in all of them.
And it's the exact same thing. It's basically the maximum age is given by these coal samples, which doesn't actually mean that you're detecting their age or that there's carbon-14 in them. It means that you're doing the same thing. You're just detecting the residual carbon, which is why you're getting the maxed out age. Because the machine's always going to give you a reading, right? It's not going to ever come back with infinity on the age. That's not how they're calibrated. And again, we haven't actually detected this carbon-14 in the coal. Although there probably is some, because again, there probably are some nitrogen-14 atoms floating around in there. And yet, again, we're just detecting the maximum age, which means we're detecting the minimum amount of carbon-14, which means we're just detecting residual carbon, or we're not detecting enough carbon-14 to differentiate between it and residual carbon, which means you're not reliably detecting carbon-14 in these coal samples. Weird, right?
And the evolutionists would say, first of all, there's no carbon-14, and secondly, there
They don't actually say that.
couldn't possibly be the same amount. Guess what?
Actually, I would predict that there would be the same amount, which would be virtually none and consistent with whatever the rate of the generation of carbon-14 underground is, which is going to be very low. And also, you still haven't reliably detected carbon-14 in coal.
It's the same amount, and there's carbon-14 present.
Yeah.
Dr. Russ Humphreys made the prediction about Uranus, the outer planet, that it would have a magnetic field.
Okay, Russ Humphreys, we're going to talk about how this works. Okay, Russ Humphreys had this hypothesis that God made all of the planets out of pure water. So when he made all the planets, they were all pure water. And then he made the further assumption that God had aligned some significant fraction of these water molecules such that their polarities lined up, producing an effective magnetic field, which then, when God transmuted these waters through whatever alchemical means into whatever the planets are made of now, these fields were residual and are now decaying because there's no way to strengthen them. Now, he used the degree to which the magnetic field, the water molecules were aligned. He used this factor. I think he used the symbol K for it. But you know what the fun thing about K is? It has no lower bound. It has an upper bound based on the mass of the planet and how much water that would take. But it has no lower bound. Which means anything from the maximum amount of magnetic field that you could get from a planet of that mass made completely of perfectly aligned water molecules, all the way down to 0, is what he predicted. Unsurprisingly, basically every planet has somewhat less magnetic field than it could if it were all made of perfectly magnetically aligned water. Which means he basically predicted every possible value for the magnetic field. Which means he didn't make a prediction. Now, secondly, the prediction that he kind of made for each planet was basically just based on their mass and picking a value for K more or less out of a hat, but one that kind of worked for Earth. And it turns out that when the initial flyby was made from one of the Voyager probes, I don't remember which one, and the magnetic field was measured, it did seem to align with that proportional magnetic field based on the mass of Uranus, based on Earth, which was unusual. Scientists weren't predicting that would be that strong. Yeah, guess what? We've now taken subsequent measurements of the magnetic field strength, and they're actually not nearly as strong as we thought in the first place. So, yeah, even if this was a good prediction in the past, it isn't anymore, because it turns out, looks like our initial measurements were wrong. Too bad. But hey, it's okay, because remember, that K factor can be any value down from 0 up to the maximum, which means Russell Humphreys still predicted it, I guess, because, it's almost completely unbounded, which means it predicts almost every possible value, which, is fun. Let's see. Pegajay says Voyager 2 is the only probe to ever visit Uranus or Neptune. Okay, yeah, so I guess it was Voyager 2. I couldn't remember which one it was. Although, isn't there another one on the way or something? I don't actually remember. I don't keep up with space probes nearly as much as I probably should. It doesn't come up as much as a lot of the other stuff, so I just don't really have the opportunity to study it. Because the thing is, at this point, unless creationists are saying really stupid things about it, I usually don't have time to just look into it. Because I spend a lot of time looking into the nonsense they're talking about, and it very rarely intersects with what probes are going into the solar system. So, yeah.
And he predicted what the magnetic field would be. The evolutionary astronomers said, oh, no, Uranus would have no magnetic field because it's too old and too dead.
I don't think that was ever their prediction. They did predict a weaker magnetic field, which turns out probably is true, actually. Vadim Radchenko says, was it the Voyager mentioned in Star Trek or the other one? It was definitely not the one mentioned in Star Trek, because the Voyager that is important to Star Trek was Voyager 6, a fictional probe that has never been launched. So the idea in the Star Trek timeline is that NASA released 4 more Voyager probes. The 6th one fell into some kind of wormhole or something and was transported to the vicinity of a planet of thinking machines, which then upgraded it and noticed its initial programming of learn all that can be learned and return to your creator. And then sent it on its way. And then when it arrived on Earth, it could not comprehend the idea that humans or other carbon-based life forms were actually its creators. And it thought of them as just an infection, and then it threatened to, destroy all life in the solar system. And then luckily, Captain Kirk, as well as the dad from Seventh Heaven, back before all of the crimes were revealed, then went and saved the day. With Spock also doing a whole bunch of stuff about like flying through like kaleidoscopes or something. Heather Schrodinger's Fossils Coon for $5 says, given the amount of radon found in basements in coal country, C14 in coal could easily be formed by radiation affecting the nitrogen 14 in the coal. Yeah, that's the thing. Like carbon 14 forms underground. It's a thing. Like it's a real thing. Now, does it form in significant amounts that we could easily detect? No, probably not. Max P for $5 says, the Voyager 2 measurement was because of extreme solar wind conditions, Jansky et al. 2024. Yeah, that is what I was thinking of, but I couldn't actually remember the paper, so I tried not to cite it, because remember, these are live, and I don't know what I'm going to have to say or look up, so thank you very much, Max P. I really do appreciate the Jasinski et al. 2024 citation, because that is, in fact, what I was thinking of with the much more recent measurements. I guess it was actually the reassessment of those measurements. So, oops. Sorry, but this correct prediction from Humphreys wasn't even the actual predicted value.
After billions of years. 2 years later, Voyager 2 flew past Uranus. Guess what? It had a magnetic field and almost exactly what Dr. Humphreys predicted.
Which isn't actually the native field strength. I'm just going to take a drink for how great it is that they wrote for decades. And they're like, oh, look how great this is. And then here comes 2024 with like slapping them face like a big wet tuna. And saying, nope. And yeah, my mental image is a gigantic tuna fish being slapped into Don Batten's face.
Wow, that's pretty impressive to predict something, physics to do with something that's a long way out in space. That's amazing.
And then to get it wrong, while also making predictions, they're so wide-ranging that virtually any value would be counted as a prediction, which even means the new value for the strength of the field of Uranus's magnetic field is still within the predictions of Russell Humphreys. He just has to change that K factor.
Amazing. Yeah. I was actually chatting to Taz Walker, Dr. Taz Walker, the other day.
Oof. I've done some videos on that guy. I don't think he's as bad as Andrew Snelling, but he's not much better.
And he mentioned another example, which I thought was fascinating. He was talking about opals, and there was a creation scientist, he was a creationist opal miner, and with a bit of science background. And he thought, I don't believe people when they say opals take millions of years to form. So he actually went out to try and make his own opals, and he found a process in jam jars and some special liquid and sediment to start making opal in a matter of weeks. And I thought that's fantastic that with that biblical understanding of history, he could actually make a prediction, do some real science, and it came true. And I just thought that was such a great, so many good examples. Yeah.
That's not an example of anything. The fact that humans can perform a process quickly doesn't mean that process happens that quickly in nature. Like that's not how that works, right? Like humans can insert dynamite all throughout a mountain and remove huge sections of the mountain in like a few days. That doesn't mean that that's how fast mountains erode naturally. Humans are great at accelerating natural processes artificially. Now, I don't know what opal miner this guy's talking about or what opal making process he's talking about. I also don't care, because nothing about humans finding an artificial way to produce a substance faster than nature produces it in any way means that nature produces it that fast. That's just not how it works, right? Humans have found ways to turn like biological waste matter into something that resembles crude oil very quickly. It's not terribly efficient, which is why it's not really done commercially, but it's possible. that doesn't mean that it happens naturally. And yeah, Vulpix, half fox, half canine says, special liquid. Hopefully it's not that kind of special liquid, because I would not want those particular opals. But, hey, I'm not buying opals, so I guess I don't have to worry about it.
Yeah, it is. And in fact, the whole junk DNA thing has harmed science because
it really hasn't. It's just true.
it's said to scientists, you don't have to look at this because it's got no function.
Okay, hold on. I'm going to take a drink. If the idea of junk DNA, which was proposed and well accepted long before ENCODE, had stopped scientists from looking for function in what they had designated as likely junk DNA, then why did ENCODE bother? The very fact there was an ENCODE project is good reason to suspect that no, people didn't decide to just not look for function in DNA because they expected most of it to be junk. In fact, there was a whole genome-wide survey looking for function in all of the DNA. How could it be possible that the idea of junk DNA hampered scientific investigations into the function of DNA when there was a genome-wide assessment for functionality? Those two things can't both be true at the same time, my guy. The very existence of ENCODE shows you're wrong about this. You're being very dumb, Dawn. Taking a drink.
And so for decades, basically, the whole junk DNA paradigm has harmed the progress of science. And it's unraveling, and scientists are being forced basically to recognize that this so-called junk is not junk.
Yeah, except they're not, though, because the 2014 paper from a decade ago from ENCODE stands to this day as basically being in line with the current consensus, both of geneticists broadly and ENCODE themselves. The 2012 paper was partially retracted 2 years later. 2014 paper, never retracted.
Well, one of the things they found was that when they started looking at the genetic basis of cancer, they found that cancers were caused by mutations in the junk DNA. We say, oh, hang on, if mutations in the junk DNA cause cancer, that can't be functionless.
It's not junk, is it?
It's not junk, no.
What? What? Okay, I'm taking a drink. Okay, this is mostly just water now. I'm gonna be right back. I'm gonna collect my thoughts. I'm gonna get a new hard Mountain Dew, and we're gonna come back and we're gonna talk about just how stupid the idea is that if a mutation in a part of DNA can cause cancer, that means that DNA was functional in the first place. I'll be right back. I need to calm down a little bit and get a fresh drink because, oh boy, is that dumb. I'll be back in just a little bit. Okay, we're back. I mean, I'm back. I always say we're back because I'm used to having a guest. All right. No new super chats to read. So, I'm going to continue with my analogy, a similar analogy at least, to the idea with the little ceramic figurines from your grandmother. Let's instead assume that we've got a guy who has an attic, and at one point, he put a hammer up on a shelf somewhere, right? That he doesn't even know that hammer exists anymore. It's, we'll change it to an axe because it's probably a better option. So there's an axe up there. The steel axe blade has been rusting away for decades. So if you tried to use it to chop down a tree, it would be pretty useless. And this guy has forgotten that it even exists, right? Probably junk. So, let's say one day, he bumps into something, which knocks the axe down, and it falls on top of his head, and he bleeds out in that attic. Is that evidence that the axe was beneficial or functional? No! No, of course not. The fact that you can have some bit of DNA that's not doing something until it mutates, and then suddenly it starts doing something harmful, isn't evidence that the purpose of that DNA was to not mutate to cause cancer. What does that even mean? By that definition, I guess your entire DNA has the function of not being cancer? Does anyone actually think that's a reasonable way to talk about function in DNA? Like, well, it's not causing cancer, so I guess its purpose is to wait around and hopefully never cause cancer? What are we talking about here? How could you possibly get from this could mutate to become harmful to it was functional for that reason? That doesn't make a lick of sense. Also, I've switched to Livewire, and I'm taking a drink of Livewire because I can't handle that much stupidity. Does anyone have a way in which this can make sense? If you do, send it to me. Because I cannot understand how anyone could think that a mutation could occur in a part of DNA that causes cancer means that that bit of DNA is therefore functional. For one thing, if it required a mutation for there to be any effect on the organism in the first place, that means there was no effect of that DNA as it was before, which to me makes it seem like an argument against functionality. Don't forget to ground myself. Alright, I'm firmly touching the ground. I'm sure that any discharge will go through in that direction. And Robert Atsit gifts a membership. Thank you very much. So we will take a drink for that membership. Okay. Well, I think Beethoven might end up starving, but that's okay, because we're going to get a little bit more in here. There's only 4.5 minutes left of this entire video, and I suspect that a bunch of it is just going to be commercials or become a Christian pitch. Which, again, I've said it many times before. If you guys want to convert to Christianity, or you want to stay Christians if you already are Christians, I have absolutely no problem with that. Go for it. Have fun. Feel like you guys know the basic pitch of Christianity. Volis for $10 says, yeah, that last statement needed to be brain bleached away with a Godzilla. Yeah, well, hopefully that's what this hard live wire will do. I'll take a drink for the Godzilla. And of course, increase the value on the donations counter. We got to 50%. That's pretty good. All right, here we go.
Yeah.
So,
No.
It's really impeded the progress of science. If they'd taken a creationist approach, science would have progressed much faster.
I'm going to need a citation on that one, buddy. Because the only thing that you have said about that is that they would have looked for function in more of the DNA. But they looked for function in all of it. Literally all of it. In humans, at least. I can't imagine how much more than all of it he would want scientists to look at. You want them to check 3 times? They probably checked a whole bunch of times.
So with all the evidence that's going against evolution.
Of which none has been provided.
Why don't we see teachers, professors, lecturers teaching, creation science? Why do they keep teaching evolution again and again?
Because it fits with the data. That's why. Like, that's literally it, right? It's like why all the scientists keep teaching about the globe Earth. Because all of the evidence corresponds with that. And remember, the only thing this guy has said that has actually been a failed prediction revolved around models of galaxy formations in the early universe, and he exaggerated the degree to which those predictions failed. Everything else has either not been a prediction of evolution or not been actually true in the first place, and in most cases both. He's literally given no reason to doubt evolution on almost any scale, or to doubt the Big Bang, or to doubt, our geological sciences, taphonomy. None of these has he given a reason to doubt. The only thing he's had is, hey, models of early galaxy formations are probably off a bit. Which, you know what? They probably are. I'll give that to you.
Well, some of it's ignorance, because they're going through a system which only talks about evolution, and it talks about it in a way which that's the only acceptable way of looking at things.
That's not ignorance. That is just what the literature has. Creationists are welcome to publish papers contrary to the consensus. Many papers are contrary to some consensus or another. The problem is that you don't actually have any evidence to publish about. Creationists aren't excluded because of bigotry or bias. They're excluded because there's no there. They don't have anything.
So that's a problem. Ignorance is a problem. But there's also willful ignorance, and that is the alternative to the whole evolutionary scenario is what? There's only two ways of looking at things. Either things made themselves or God created them.
The phrase "things made themselves" is almost never how anyone would ever describe any of this stuff. It's just a way to give a funny sounding explanation to science such that it becomes less credible in the eyes of ignorant audience members. Scientists do not describe organisms as making themselves. Or planets, for that matter, or stars, or anything else.
And the thing is that God created them is unacceptable to so many people.
Who cares? If you actually had evidence, you could present it. Whether or not it's philosophically unacceptable doesn't matter. Because remember, when the Big Bang was proposed, a lot of scientists found it philosophically unacceptable. Fred Hoyle famously opposed it for his entire life on the basis of it being philosophically unacceptable to him. He literally thought it sounded too much like Genesis, and he was an atheist, so he rejected it. You know what happened with the Big Bang? It became the consensus despite the huge amounts of bias against it based on philosophical grounds. From atheists. And guess what? Now it's the consensus, despite those previous philosophical objections. So the Big Bang itself is evidence that this claim that people just don't want to accept the evidence for creation, or for a short age of the Earth, or for whatever, just isn't true.
And so the only alternative they have is to hang on to the evolutionary idea, in spite of its problems, in spite of its failed predictions.
You would think that if there were so many problems and failed predictions, he could have produced, any.
In spite of it impeding the progress of science.
Which it hasn't done by anything that he said, because remember, his only claim was, well, they would have looked for function in more of the DNA. Except that they did look for it in 100% of the DNA.
They hang on to it because the alternative is unthinkable. Richard Lewontin was a professor at New York State University.
Okay. Creationists love to quote Richard Lewontin or Lewontin. I've heard it both ways. I don't really know. I don't really care. I can't think of anything I care about less than stuff that Richard Lewontin said in things that weren't even peer-reviewed paper. Or papers, I suppose. Sorry. The Mountain Dew is getting to me. I just don't care what Richard Lewontin said. I'm not a disciple of Lewontin. I'm not a Lewontinist or Lewontinite. I just don't give a shit about what he said, which means that while he's quoting Richard Lewontin, we're going to put him on a fast forward so we can get through it. Because you know what my response is? Okay, some guy said a thing. I don't care.
United States. And he said, we hang on to this materialistic idea because we cannot allow a divine foot in the door.
Wow, that's quite a statement.
Yeah. So no matter how counterintuitive it is and how it fails so many things, we hang on to it because the alternative is unthinkable. That God created things. And why? Because God made us, we're responsible to God, and we're not free agents to do whatever we like.
Yeah, it's a shame that that's the case.
Actually, that doesn't follow. So he just said that if God, then this is not him quoting Lewinton. He said if God exists, then we're responsible to him. No, that doesn't follow. There could be a God who just doesn't give a shit about you, who doesn't care what you do, or who does give a shit about you, but who thinks you're just doing A-okay and isn't going to hold you to some account afterwards. That's at least a logical possibility, because remember, the options aren't godless atheism and Christian theism. There are an infinite number of other possible things that could be true. There could be gods that just don't care. There could be gods that do care, but aren't going to punish you posthumously. There could be gods that do care, might punish you posthumously, but aren't going to do it infinitely, like his version of the Christian God. All of these things are options. There could be multiple gods who are responsible for creating various different parts of the world, some of whom care about what you do and some of whom don't. Like, all of these are things that are possible. Alex Marco says, wait, Mountain Dew turns you into the king of sass? Well, hard Mountain Dew helps. Benny Marchenko says, Platonic demiurge? Yeah, there could be that, right? There could be the high god who cares to some degree about what you do, but isn't going to be, like, getting involved in affairs or, like, judging you after your death, but instead is going to allow what spirit essence you have drawn from him as an emanation to work itself out until you reach some kind of saving knowledge, which will then itself allow you to access him no matter what you've done in your previous lives. Whereas the god that created the physical universe is, to some degree, an evil or at least misled or unwise god who created this dirty physical universe. That's another belief that's been held. That's at least as much possible as any of the other theological positions. So, no. Philosophical atheism and Christian theism are not the only options. So, if you're a philosophical atheist, it does not have to be because you're scared about being judged. Because the other options are not all things about you getting judged in the first place.
But it does make sense. So can you summarize the 5 failed predictions of evolution?
Okay.
DM says, you all right, Dapper? I'm probably fine.
Okay, so the first one was the presence of mature galaxies where they shouldn't be.
Which is the only thing that he was even half right about.
The second one was the planation surfaces that should be eroded around the world. And
which, remember, he couldn't even figure out the difference between the age of the surface and the age of the rocks that the surface is made of. I'm taking a drink for it, because that one was especially dumb.
they're not, because they're supposed to be so old, they should be severely eroded. The third one was the presence of soft-bodied fossils, which shouldn't be there if the rocks formed slowly and gradually over millions of years.
Which, again, he's exactly wrong about. That's the only way they could be there.
The fourth one was the inability of evolution to invent things like rotary motors or even a wheel.
Which wasn't even a prediction. It was a mix-up between Haldane's dilemma and other ideas about unevolvability, which have so far been shown to be true. And Haldane's dilemma, which wasn't even a prediction, it was just a problem to be solved, which was then solved.
Or magnets, and of course
it's part of the same thing.
We find them. And the fifth one was a prediction that most of the DNA in humans and other complex creatures is junk.
Which was true the whole time.
Which it isn't. So these are the 5 failed predictions that we've dealt with today.
Excellent. And
all right, well, that music means that we're not going to get any more claims because they're just going to do some wrap-up stuff and tell us which websites to go to. Go to creation.com if you want to hear more from these guys. Feel free. I don't care. All right, well, that means that we are done for now. We went, about 40 minutes over our normal time. We got to 50%, which is not enough to get Bent a free pizza, but it is substantial. So I do want to say thank you. Let's take a look at what is coming up here on the channel in the coming days. So, let's see. Let's go over to, we've got Andrew Snelling is Still a Liar, the movie. That will be coming up on Thursday at hold on, at 11 a.m. Pacific. Nope. Yep. 11 a.m. Pacific, 2 p.m. Eastern. I'm sorry. That one will be a bit of a lengthy one, so that's one of the ones where I recommend, like, this is longer than just a regular lunch break. Bring a snack, bring a drink, settle in for a pretty long video. But that is Thursday, so let's go back up to Tuesday. Tuesday will be Jackson with Jackson. That will be at 6 p.m. Pacific, 9 p.m. Eastern. We are going to be continuing with our ongoing look at the nonsense of Charles Jackson. Then on, let's see, so we already went over Thursday. It'll be the Andrew Stelling is Still a Liar, the movie. Then on Saturday, I'm hoping to be continuing with the Neil deGrasse Tyson versus Hugh Ross about biblical interpretation and whether or not you can get modern science and physics out of the Bible if all you had was the Bible. Remember, in the first part, all Hugh Ross did was show that Neil deGrasse Tyson was right while trying to argue against Neil deGrasse Tyson. It was very weird. Then on Tuesday, we will be at 5 p.m. Pacific, 8 p.m. Eastern. We will be doing Kent with Bent. Now, here's the thing about December. So normally, Matt with Maddie is on the third Tuesday of the month, and Jackson with Jackson is on the fourth Tuesday of the month. However, December makes that a little bit complicated because the fourth Tuesday of December is December 24th, and I know that that is an inconvenient date for most people to do a show. So what we are actually going to be doing is on December 10th, which is the second Tuesday in December, which would normally be a Kent with Bent, we are going to be doing Jackson with Jackson. And instead, Kent with Bent will occur on the 24th, which will be Christmas Eve. So there you go. By the way, when I say that the show on Thursday is going to be long, it is 2 hours, 55 minutes, and 13 seconds. So it is a pretty long one. Max P, who's been a member for 4 months and is at the Tetrapod level, says, shouldn't this be Dapper Reacts 97? Maybe it should. What did I put on the thumbnail for this? Did I put 97 or did I put 98? I don't actually remember. Let's take a look, because you could very well be right. Carnival Frog, who's been a member for 8 months and is at the Tetrapod level, says, I just missed it. Have to watch later. Hey, that's okay. I think it was a fun show, and it was here for you to watch later. So let's see. What did I put on this? I did put 98 in the thumbnail. Should it have been 97? Was the most recent one 96? Let's see. Tyson Verder. Yeah, it should be 97. All right. Well, here's what we're going to do. I'm going to put this as Dapper Reacts 97 here in the title. And I'll put the thumbnail is wrong in parentheses. Boom. But then also Carnival Frog just gifted 5 Dapper Dinosaur memberships. Thank you so much. I will take 5 drinks before we get out of here. 1, 2, 3, 4, and 5. Thank you for pointing out that I got the number wrong. It definitely happens. All right, everybody. I will be, in just a few minutes, heading over to my Dapper Dinosaur Discord server, where we will be watching the final 4 episodes of Power Rangers RPM, one of my personal favorite seasons. So, if that interests you, head over there. Otherwise, I hope you have a wonderful, safe rest of your weekend, and that you have a wonderful Thanksgiving holiday if you're celebrating that. Maybe you're here in the U.S. So, stay safe out there, and I'll see you later. Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Benthoven, Thurrevara, Tapioca Weasel, Whispers, Elron Teller, Ian Chen, Calvin Brostig von Manen, Landon Knoll, Mabbity Babbity, Sphincter of Doom, Flawless, Edwin M., North Texas Fossils, John Ackerman, and Strawberry Vein. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.